Good morning, everyone. Can you please confirm if you can hear me? Let me ask a quick poll question. Can you hear me? Yes.
Yeah, Enoch, it's audible.
Awesome.
So you might want to give the giveaway first for
All
the
right.
people who have participated in the quiz. And by then, the people are going to join and we will take it further.
All right. So let me quickly share my screen. And we have about, let me check. We have about 282 people that have participated in the quiz that we have posted both on Facebook and LinkedIn. And now we are going to randomly pick one person and then we are going to give them a gift. So let me do a quick, just to be fair to everyone, we are going to randomly pick the person. So let me find the random number generator and serial number 1 till serial number 282. So I'm going to put 1, I'm going to put 282, and the moment I click on the generate button, whatever the number that comes up on the left, that person is the winner of today's lucky draw. So without any further delay, let's do this. 3, 2, 1, and go. So the winner is the person with the number 22, serial number 22. So let's go find number 22. And it's Anuradha. So Anuradha, congratulations. And we will get in touch with you. We have your details. We will get in touch with you and we'll give you the gift card. Thank you so much. And today, watch out for our WhatsApp groups. We will be posting the links to the quiz after the session. And
Yep.
over to you, Bharat.
Congratulations, Anuradha. And I really appreciate everyone who is participating and then contributing. And then, yep, that's an amazing thing. So, Enoch, would you mind posting even the WhatsApp link here?
Uh, I'll do that. So let me do this. Whoever is not yet part of any of our WhatsApp groups, just put up your message and I'll private message you the WhatsApp joining link. So the moment someone types in that they do not have WhatsApp, they are not part of any WhatsApp group, we are going to privately message you the joining link. Yeah. Over to you, buddy.
Wonderful. Yeah. So please post the YouTube link. Sorry. Yeah. People who haven't watched, I request you all to watch this. So we are going to post this on the sticky note also. Enoch would do that. So let me share my screen and let me show you this. No, there won't be any assignments for this. Yeah. Assignments is part of our a different program, which is a full length. Here, assignments do not make sense because um, assignments won't be straightforward and then it's just going to cause a lot of confusion. So here we have all these videos, 9 videos. The ninth one is live now. So you have roughly 8 videos which are available. I request you all to watch these videos. Each video will be for 3.5 hours long. Okay. And watch it and try to make best use of that. And please do not forget to subscribe so that you're notified whenever there are newer questions which are posted. Okay, having said this, there are 4,447 people who are viewing these videos. That's amazing count. There are 9 videos, 8 of them are there, and the ninth is today. We'll continue in this way, and whatever we can complete in 20 days, we will do that. So today is the ninth day. All right, welcome once again, everyone, to this session. As usual, we will do a quick recap even before we proceed further. Our mind map has been updated for AI and deep learning. Here is a mind map link because this mind map also has the other details, such as you can access data science, cloud computing. We will have in comprehensive cloud computing AWS, Azure, Microsoft Azure, Google Cloud Platform, and IBM Watson. All these would be available. And if someone wants to go with AWS Cloud Solution Architect, that is also available. If someone wants to get themselves accustomed to only machine learning using Python and R, they can do that. If they want to proceed further with data science, that is also available. Big data, Hadoop and Spark, we have that. So all these mind maps are not something which is static. We dynamically keep updating these mind maps once in every week, once in every 2 to 3 days, something on those lines. So each time you view that, you'll see a new list of entries. So I click on this. So here are the new things on the mind map. We believe this mind map should serve as a one-stop solution for everyone. We believe it will serve that purpose. So if you look at project management methodology, we started off by discussing about crisp DM, wherein we have this understanding the business problem, then you collect the data, then you cleanse the data, and then you proceed further with supervised learning or predictive modeling. In this, you have a lot of black box techniques, wherein we have neural networks. Okay, and these are the various networks which exist, in which we have already discussed about perceptron algorithm, and we discussed about multi-layered perceptron algorithm. And we will also discuss about CNN, RNN, but CNN has a very strong correlation with computer vision. And that is the reason we are now discussing computer vision and image processing stuff, in which we discussed about the various challenges that we have. What are the various image transformation techniques? We have point operation, local operation, and then global operation. Then we have discussed about noise reduction techniques such as moving average, 2D moving average. What do we mean by a filter, kernel, mask? We discussed about these. Then we discussed about how to handle boundary effect by doing padding, zero padding, wrapping, clamping, mirroring. And then we have also looked at template matching. Until here, we were able to understand. Now we need to take this discussion further and discuss about a few more things. And alongside, we have been using OpenCV, which is a de facto library which is used to handle computer vision applications, to handle computer vision and image processing kind of applications. Okay, so there we go. So OpenCV is something that we installed and we have done a lot of operations. And I need to quickly, sorry, need to check here on until where we have, you know, discussed in terms of programming. Is this a last one or okay? Yep. We discussed until how to split the various color channels, right? That's, I think until there we discussed. And we split the color channels into red, green, and blue. Okay, and the code is very, very clearly visible. The data sets are uploaded on your learning management system. I mean, the image that I use, I'm going to upload. And you will have to actually ensure that you look at this code and type it on your computer. That is exactly what we are interested in. All right. So I'll have this open so that towards the end I again post that. So now I think it is time that we get started with computer vision. And we will get started from where we have left. Edge detection. So if at all an image is provided to you, we know for a fact that image can be split into multiple rows and columns. In some sense, these are called as pixel intensity values. Each of the pixel value ranges from 0 to 255. 0 means black, 255 means white. So you have black and you have white. And you take each of these pixel values and you load them into your dataset. So you can move this and make your data look structured. Whenever you have limited data at your disposal, when you have less number of images, etc., then what people usually do is they manually extract the features. You manually extract the features and like pixel intensity values. Pixel number 1, pixel 2, pixel 3, pixel 4, 5, in that way. You take all the pixel values and all these pixel intensity values will start behaving like your inputs. And output could be, is this a cat or is this a dog? Those kind of things. The good part is, if you can convert your images, which is unstructured in nature, Okay, and if you can convert this to a structured format, then you can use this structured data. Okay, and then you can actually uh, apply your traditional shallow machine learning algorithms. Like you can apply logistic regression or support vector machine or KNN or naive Bayes or any of those. Okay, just a moment. I think there is some noise which is disturbing me. Okay, sorry about that. Someone's vehicle. Okay, so this is the beauty, right? And another good part here is if you manually extract the features, another good thing is you will retain the interpretation part. You exactly know what is being extracted. You know that these values inputs are pixel intensity values. At least you know that these are the inputs. However, on the contrary, if you use these images and supply these images to your deep learning algorithms, and nowadays deep learning means neural networks, okay, different neural network algorithms. Okay, when you give it to your deep learning algorithm, features are automatically extracted. Automatically features are extracted. When features are automatically extracted without your effort, this is certainly a good thing, right? Because you are not doing any manual extraction, so you're saving a lot of time. While this is a good thing, the bad part is there is no interpretation. The new features that are extracted, like these new inputs, you don't know what those are. Okay, no interpretation exists. There is also another thing, wherein if you all are aware of regression techniques, when you write the regression model like this, okay, then you can easily interpret these values. What do I mean by that? Say you want to predict on what will be the weight gain of a person. That's the output, assume. So weight gain is equal to maybe 12.9 plus 1.6 into calories consumed, okay, plus 1.2 into age. In that way, you will get these numbers. And then you can use these numbers, calories consumed and age. You can substitute in this equation, and then you get the weight gain in typical regression techniques. Okay. And this 1.6 means that for every 1 unit increase in the calories that you consume, that means calories are measured in kilocalories, right? Usually. So if the calories consumed increases by 1 unit, the weight gain increases by 1.6, all else being constant. Okay, if you increase the calories consumed by 1 unit, I mean 1 kilocalorie, then weight gain or the weight will increase by 1.6. Yeah, weight if it is in grams by 1.6 grams in that way. But then when it comes to your neural network, you'll have an equation like this: B plus W1 x1 plus W2 x2. You'll get some numbers like the numbers that you have here. But those numbers will have no such interpretation. So one is the parameters that your model learns, the weights that your model learns have no interpretation. Another thing is the features or the inputs which are automatically extracted would also have no interpretation. But if you're working in, say, life sciences, healthcare kind of scenarios, okay, and in life sciences, healthcare kind of scenarios, when you build a, say, cancer prediction model, without interpretation, Medical Council of India or any of the governing bodies will not approve your model for usage, right? For usage in hospitals, etc. They will not allow. They will say, hey, there is no interpretation which exists. Why do I need to even rely on the model that you have built? Okay, so to counter that, people use these kind of shallow machine learning algorithms for which you have to manually extract the features. The first raw feature that is extracted is your um, pixel intensity value, and the next raw feature which is usually extracted is edges, and that is where we are. This is called as snakes and saccades image that you're seeing here, and you get an illusion. When you look at this, you get an illusion that these snakes are rotating, right? But in reality, none of your images here are rotating. You get an illusion, right, that these images are rotating. You get such an illusion because of the edges in the image, right? Because of the edges that you have, you feel as if it's rotating, but actually it is not rotating. Okay, this is called as snakes and saccades. Okay, all right. And a few years back, if you remember, people have posted this image, and this image became extremely famous. Do you know what this image is? This image is an image taken by Mars rover. The robot which is used to explore planet Mars is called as rover, Mars rover. Okay, and Mars rover keeps taking the videos and images of planet Mars, and it explores planet Mars. And this image, people thought this is a woman, okay, and she has just fetched. They thought that this is water, and she is standing there fetching water from the pot, okay, and then yeah, that's what people thought. But ideally, when NASA has actually figured out further on, is it really a woman? Do you think life exists on planet Mars? Because Mars supposedly is very close to Earth, okay, in terms of various things. And that is the reason why they thought it's a woman. But then later on, they figured out that this illusion that is created is because of images, shadows. Okay, that's a slight motivation for you all to understand about edges. Now here, if you look at an image, as I've told you, image contains pixels, which is the most raw feature which can be extracted. When you feel that you can analyze the pixel values and use it for your further analysis, then the disadvantage here is that you need to use all the values, all the values, all the pixel values, and place it. Your data set might become extremely large. If your data set is extremely large, it takes a lot of time to do the processing. Hence, what people thought is, can we not extract only the edges? And if you look at only to figure out on what is there in this image, do you need all the pixels? Do you need pixel 1, pixel 2, 3, 4? Do we need all these pixels? Absolutely no. You just need the edge pixels, maybe. And that too, you need not have the entire edge. Just a few edges are good enough for you to say that this is a human in the image, this is a horse in the image, and this is an airplane in the image. You can make out just by looking at the edges. That too, you need not look at all the edges. You can look at only a few of the edge pixels, and you can make out on what that image is. Okay, then it is much more compact than all the pixels put together. It will be very, very fast in terms of processing. Hence, it is very important for us to understand about edges, which are also a few features. Like you have pixel intensities, we also have edges, which are also features, which can be extracted and used for your predictive modeling. Okay, and then edges are caused by a variety of factors. By variety of factors. For example, whenever there is depth discontinuity, you'll have an edge. For example, depth means how far or how close objects are to you. If you look at this building, this is close to you in comparison to the sky that you're seeing here. You have sky and you have building. Building is much closer to you than sky. So there is that depth discontinuity. Hence, you'll have an edge over there. Okay, you'll have an edge here. And in comparison to this building wall, this railing is much closer. So there is again depth discontinuity. This is far, this is closer. So there'll be an edge here. Whenever there is illumination discontinuity, meaning here it is bright, here it is dark, bright and dark. So you have an edge over there. Surface color or surface appearance discontinuity. Here also you have an edge. So for example, this is of a different color and this is of a different color. So you'll have an edge over there. Then you have surface normal discontinuity, meaning if you go around this, there is an edge over there. Okay, and also look at this edge. Where do you find edge in order to understand that? This is the intensity representation of your image. You have an image, you're representing that image using intensity values, and here you have a function of x comma y, which is nothing but intensity values, and then you have your x-axis here and you have your y-axis here. You have your x and you have your y and you have your intensity values. Here you'll have 0 and here you'll have 255. 255 means white, 0 means black, right? And if you observe it carefully, if you take this portion, it's all white, 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 white color, white, 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 white. Then it is slight gray, and then it's black. So if you look at this portion exactly, there is a sudden change in the intensity values. There is a sudden change. Here it is white and here it is black. So I mean suddenly from around 250 or whatever be the values which are closer to 250, your pixel values are switching to black. Hence there will be an edge. Here also it's the same case. You'll have an edge. So you'll have an edge like this wherever you have a sudden change in the pixel intensity values. Wherever you find a sudden change in the pixel intensity values, there will be an edge. Same is the case with this also. Suddenly there'll be an edge. Again, suddenly there'll be an edge here, here, and then here. Okay, so change in intensity values is determined using rate of change. The rate at which the pixel intensity values are changing from here to here is called as rate of change. Okay, rate of change is sudden change in the pixel intensity values. Rate of change is also called as slope, which is also called as derivative, which is also called as gradient. Hope you are aware of these things from our mathematical foundation session, which was covered earlier. Okay, so rate of change is also called as slope or derivative or gradient. So let's look at this derivative. All mean the same. Each of these mean the same. That means if you find the derivative of the function, derivative of this function, remember images can be represented as functions. So if you find the derivative of the function, wherever the rate of change is the maximum, that is where you'll have an edge. So say this is a function. Edge means wherever you have a sharp variation, maximum change in pixel intensity values. So what do? You just take the first derivative. And when you find the first derivative, look at that what's happening. It's all same here. So it'll be the same here. It's changing. So it will start changing. At some point, the rate of change is becoming stable and then it's getting stabilized here. So it's coming down and here it will actually get stabilized once again. So here you have maximum rate of change and then that is where you'll have an edge. To explain this better, let us take this another image. Okay, so this is an image that we are going to discuss about, but then do not mistake this red line to red color. No, this line is only there to represent that. We are going to take only this row chosen for analysis. Okay, this is the row which has been selected for our analysis. Okay, hence it is just differentiated by using a red color. That is by no means a red color, just that's a row from this image. Now, if you take only this row, what's happening here is it's all white, white color throughout. And there's a small transition from white color to gray color to black. So white means 255 and black means 0, right? So it's all same until there. And then there is a slight transition from white to black. So you have a slight bend. And then you have to come to black because suddenly it is black. So you come to black. And then it's all black throughout here. Throughout it is black here. And then there is a slight transition once again from black to white. It goes to slightly changes and then it becomes gray and then it again ventures into white color. If you have such a representation, okay, and if you find the first derivative of that, what happens? Yeah, it's something that we need to look at. So you find the derivative basically. This is, you're taking the image, you're representing that as a function of intensity values. Okay, so you're just taking one single row and representing that as a function. Once you represent an image as a function, you can find the derivatives. You find the derivative of that. And you find the first derivative. So what you do is it's all same, constant 255, nothing is changing. And then slowly it is changing. Okay, and then again it gets to the 0 part. So again you go back. This is 0. Okay, this is 0. Okay, so again it stabilizes to at 0. There is no rate of change here. Rate of change, wherever the rate of change is constant, derivative values or rate of change will be 0 because there is nothing which is changing here. Here also there is nothing which is changing. So the derivative will be obviously 0. And here also nothing is changing. So the derivative would be 0 in this portion. Okay. Then what's happening? There is a slight transition again. It's going upwards. So the rate is changing, rate is changing, rate is changing. And then the rate is getting stabilized. It's coming down and then it's becoming 255 there. So if you find the first derivative of this particular function, it appears like this. And here you have two extrema. One is this extrema is the minima and this extrema is maxima. And you'll have edge over there, you'll have edge over here. Look at that. You'll have an edge here and then you'll have an edge here. That is exactly what is being represented in this way. So it is that simple. Finding out edge in an image is this simple. You need not worry too much in terms of identifying the edges. Okay, so just to tell you here, you can also look at a function in this way. Okay, so what's going to happen is if this is your image will have x-axis and y-axis. It's a 2D. Image is a 2D representation. And you have x and y. All right. And say you have a pixel value here, which is x comma y. Some number, some x comma y. At this point, you will have some intensity values at this point. Okay. And then when I say x plus 1 and y, on y-axis it will be the same. This is x. So x plus 1 means you move by 1 pixel towards the right. And you'll get a pixel here. So you have pixel here. You're moving by 1 pixel. Since you're moving by 1 pixel here, you'll get function of x plus 1 comma y. So you take the pixel intensity value here and subtract it from the previous pixel intensity value. You're dividing it by 1 because you're moving only by 1 pixel here. So the change in x is 1. And that will give you the rate of change from this pixel to this. From one pixel to another, the rate of change can be captured. But this rate of change you're trying to find only along the x-axis. This is partial derivative of your function with respect to x. Now understand how important the optimization module that we have done is from mathematical foundations. Yep. Another thing here is if you have a value here, pixel value, okay, x and y. Now instead of x plus 1 comma y, if you were to do this, x comma y plus 1, then what's going to happen here on x-axis? It will be the same. Y, you're changing from y to y plus 1. So you're increasing y by 1 pixel. And you want to find the difference between the intensity values here to here. That's this. For that, you have to find out derivative of the function with respect to y-axis, with respect to y. Earlier it was with respect to x. And it will be approximately equivalent to f of x comma y plus 1 comma f of x comma y. This is f of x comma y. This is x comma y plus 1. And you are moving 1 pixel along the y-axis, so it's 1. The rate, the change along y-axis is just 1 pixel, so it's divided by 1. And then you solve it, you get to know what is the intensity, pixel intensity values which are changing along y-axis. Here we go. If you take this image, tigers. By the way, I think India entered into a world record in terms of the increase in the population of tigers. Right? We went on a mission to save the tigers, and the end result is too many tigers are out there. Yeah, that's a good thing for us. They didn't go extinct. Okay, so if you find the pixel intensity values, and if you find the derivative with respect to x, meaning along x direction, so you move from left to right, you move from left to right, and wherever there are pixel intensity changes, you record that. Simple. So for example, say you're moving from this direction to this direction, you keep moving in that way, keep moving. Okay, you keep moving, and here at this point of time there is a sudden change. You're moving from this black color to white, so there'll be a sudden change in the intensity values. Then again, if you move forward from it, it's going to change from white to black, and hence there is another edge there. Again it's changing, so again there is an edge. So wherever you find such changes, okay, in the pixel intensity values, even at this nose, right, for instance, if you, yeah, if you move in that direction, there'll be edges. Wherever there is sudden change, there'll be edges. Very simple. Okay, so if you're moving along x-axis, what edges are found? This kind of edges, edges like this, edges like this. These are called as vertical edges. So if you move along x-axis, the direction in which you move, in that not in that direction, but in the opposite direction, you'll find the edges, because you're moving along this direction, right? You're moving like this. So wherever there's a rate of change, you'll have an edge like that. Okay, so you'll get vertical edge if you move along x-axis. And if you move along y-axis, if you want to find the rate of change along y-axis here, along this, then let us see what happens. So if you're moving from in this direction, in this way, wherever there's a change, if you're moving along in this direction, so observe here there is prominent change to black color, so there is that edge. Then after the black is done, white starts, so there is an edge. Again, after the white stops, black starts, there is an edge in that way. So you have y-axis. If you move along y-axis, you'll have rate of change, and this rate of change that you're seeing here would have horizontal, would help you identify what edges, edges along this direction, like this. Okay, edges like this. So these are horizontal edges. Okay, so you can identify vertical edges or horizontal edges based on whether you're finding the derivation of that function with respect to x-axis or with respect to y-axis. If you find the derivative with respect to x-axis, there will be vertical edges. If you find the derivative with respect to y, you'll have horizontal edges. Next, there is also one famous edge detection filter, which is called as Sobel filter. We will do all of these things practically, okay? Using OpenCV, we are going to do all of these things. Remember simple one thing, that if you have zeros here in this way, it will find vertical edges. Okay, for example, if you're moving, why vertical edges? Because if you see, you're looking at the change from 1 to -1, 2 to -2, 1 to -1. These values, a guy by name Sobel has experimented a lot and figured out that these values, if we put in a filter, it is going to help detect the edges. So that's why we are directly using that. How did those numbers come in? There is a mathematical derivation once again. Let's not get into that. Usually if it's our, there is another advanced training of this. In that we explain about the mathematical derivations also. But here I think it's not needed because you all are getting introduced to this for the first time, right? That's the reason. Okay. So if you move from left to right, you have zeros. If the zeros are along vertical edges will be identified. Let's see. So if you move from this direction to this direction in that way, yeah, here there is a sudden change. So there will be an edge. Then after the white is done, there is an edge here. Then here there is an edge. Then if you move in this way, there is an edge. Then it's same thing. Okay, so you find the vertical edges. Then you can also find horizontal edges. The direction in which the zeros appear, in that direction edges are formed. So what happens here? Vertical, horizontal edge means you move in a vertical direction. You move in this way. In this way. If you move in this way, from here to here, there is that change, sudden change. So there'll be an edge. And then from this to this, there is again a sudden change. You'll have another line like that. And you proceed further. Okay, so horizontal edges are identified here. And then there are a lot of other edges, edge detection filters, such as Previtt, Sobel. This identifies edge along which direction? Let me ask this question to you guys. Okay, this one which I've highlighted identifies edge along which direction? Let us see. I'm going to ask a question here. A quick poll question. Along which direction are edges identified? Vertical or horizontal? Yep. Can you answer, please? Can you answer the one which I've highlighted? Along which direction do you think it is going to identify the edges? Sorry. Vertical. Absolutely. Absolutely. Whichever direction you have your zeros. Wonderful. And here it will help you identify edges along horizontal direction. In Sobel, along vertical, along horizontal. And then you also have Roberts. In Roberts, you find the edge along the diagonal like that. Diagonal. Edges are found along diagonal direction. So let us understand this quickly. This is called as grad. Grad means rate of change, gradient. The symbol is grad of function. So you find the derivative along x and also you find the derivative along y. Okay. If I say derivative along y is equal to 0, then you find the derivative of the function only along x-axis. If you find the derivative, if this part is 0, then that means you find the derivative only along the y-axis. And then you have something called as theta. When you find the derivative along both x and y, then you will have that angle theta. Theta is equal to tan inverse of derivative along y divided by derivative along x. That's tan inverse. So you have tan inverse of derivative along y divided by derivative along x. Okay. Now let me take a noisy image. When I say noisy image, there'll be a lot of noise. If you observe this image carefully, this is not completely black. This portion is not completely black. You also have certain dots, right? It's not pitch black. I mean, you have to get very close and observe. It's not completely zero. A few of them are 0, 10, 15, right? You know that 0 means black and 255 means white. But then even if you have a value such as, you know, 10, 20, 30, they are still close to black. They're not pitch black, completely black, but they're close to being called as black. And also when it comes to white, this portion is not completely white. Okay, you'll have certain gray spots like 240, 250. They are not completely white, but then they are very close to be called as white. Okay, they are very close to be called as white. So here, when you take this and plot it as a function, okay, the values here are varying like this. They're varying. They're not exactly, it's not a straight line like that, because all these values are not exactly zero. They could be 10, 12, 13, whatever be it. And then here also you have the same thing. Those changes are there. And when you have such a noisy image, and when you're dealing with such noisy images, what do you think will happen? When you find the derivative of this function, because you know what? You want to identify edge. And if you want to find the edge here, you need to find the derivative. If you want to find the derivative, okay, then what should you do? You have to find the rate of change, which is differentiation, derivative. When you find the derivative here, what do you think will happen? Whenever there is a rate of change like this, the derivative will be high, because you're finding the derivative this with respect to that, this with respect to that, this with respect to that. So there'll be huge fluctuation in your derivative also when you find the derivative of this function. This is what you get. Here you're kind of confused. Your model will be kind of confused on where is an edge, because it's fluctuating by so much. Since it's fluctuating by so much, how do you identify on where is the edge? Okay, so you take a function. In order to solve this, okay, I'm now explaining you on how to address this issue, because you cannot identify an edge if there is noise in your data. And if you have noise in your data, you need to address that. How do you address this? So what we do is, you take a function and you take a Gaussian filter. Remember we discussed about Gaussian filter, box filter, etc. Once again, I repeat, guys, please watch these videos. They are not here for fun. Okay, so I request you all to watch these over the weekend, because when you watch this once again, your understanding will become very clear. At least watch the previous day recorded video before you come to the next day. Okay, and trust me, if you keep doing in that way, your understanding will be super clear. At least I would say 60% of your artificial intelligence and deep learning part would be clear. Another 40% you can explore or you can enroll for the advanced program, etc. Right? But your understanding will be clear if you watch the videos. Okay, now back to this. So this is Gaussian filter. You take your Gaussian filter and then convolve it on this image. Convolve means it's like, as I've told you, addition, subtraction, multiplication, division. In that way, you have something called as convolution, right? So you take this filter, convolve on this image. The moment you apply a Gaussian filter on this, your image, resultant image, will become smoother. Look at this, the difference from this to this. It is a lot more smoother. Okay, and hence this Gaussian filter is also called as smoothing filter. Okay, it's called as smoothing filter. And then on this image, so what you have done is, as part of these steps, you have removed the noise, okay, from your image. The moment you remove the noise from your image or from your audio signal, whatever be it, audio signals are, audio or speech is one dimensional, images are two-dimensional signals. That's it. You need to understand this. Now, when you remove the noise from this, and when you get this image, which is a denoised image, which doesn't have any noise, now you find the derivative of this, and wherever you have a peak, that is where you'll have edge. Okay, look at that sudden changes here. So this is where you need to have edge. That is where you'll have an edge. Maximum change in the intensity values. Then there is another shortcut. Okay, here, what are we doing? We are first taking the Gaussian function. You're convolving this on this. After that, you get this result. On that, you're taking a derivative. But the shortcut here is, when you find the derivative of this function, dou by dou x of h, when you find the derivative of this, do you know how this changes? It becomes like this. It becomes like this. Okay, this is how it would appear. So what happens is, you keep on increasing, increasing, increasing. After some stage, the rate of change will become stable, and then it will start reaching the peak. So it will it will reach here, bottom. And then what happens is, because rate of change will become constant here, it won't change. Then what's happening? You are decreasing, decreasing in that way. And then after a certain point, the decreasing will become stable. And then at this portion, it will become stable. And then you start approaching this portion. So that's how the derivative would be. So what people do is, derivative of a Gaussian function, first order derivative of a Gaussian function, will always be like this. So why don't you directly take this and convolve on your image? And if you directly take that and convolve on your image, you get this. Why do you need this additional step of first taking Gaussian and convolving on your image and then taking a derivative, when you can actually have this derivative in place and then just convolve on the image? So find the derivative of the Gaussian, keep it handy. The moment you have an image, apply this onto that image. That's it, you'll get the result. Okay, so you can also find the second derivative. And when you find the second derivative, you'll get another filter, which is called as Laplacian filter. Okay, you can either have Laplacian filter with diagonals or without diagonals. Without diagonal means it will not be able to find your diagonal edges. But when you have those diagonals also, then what happens is it whenever you have such a representation where you have those diagonal shapes which have to be detected, it will very easily detect those diagonal shapes. Not just that, the beauty of this Laplacian is something else, which is here. So what you do is you first find the Gaussian, then find the derivative of this, which would appear like this. Then take this and again find the derivative of that, which will be like this. So you have a Gaussian, find the derivative of that, and then find the derivative of that once again, which will lead to Laplacian of Gaussian. This is called as second derivative. So the first derivative will give you a Gaussian like this. Second derivative will give you Laplacian of Gaussian. This is second derivative. When you have a second derivative and when you observe this from the top, this is like your black color, this is like your white color, okay? 255 to 0. Okay, and when you observe this from the top, it will appear as if there is a round shape. Okay, and as in how you peep into that, it will look black. So this round shape, imagine that as a cone that you have. And when you have such a Laplacian of Gaussian, what kind of features can you extract is a question. So let me write it down. What features can you extract? Okay, if we have Laplacian of Gaussian filter. Okay, please think and ponder on this thought while we take a break and come back. So it is 11:30 now. We are going to connect back exactly at 11:40. Okay, it's 11:30. Let us take 10 minutes break and then let us connect back at 11:40. All right. Take a quick break and come back, friends. Come back afresh. We will take this further and we will also do practically these things on our system using OpenCV. Yep, so let's continue. So Laplacian of Gaussian, when you look at it, Laplacian filter versus Laplacian of Gaussian, there is a slight difference. So anyways, when you have Laplacian of Gaussian, since you're going to have a circle on the top, or it appears like this, right? Laplacian of Gaussian filter, you can identify blob. Blob is some kind of a circular shape, and it can be used in various scenarios such as diabetic retinopathy. Diabetic retinopathy. What happens in diabetic retinopathy is that retina of an eye, okay, is of a circular shape. And people say that if you're impacted by diabetes, it will first impact your eye. So if you're going to have some kind of sight issues, you're not able to see something properly or something of that kind, that means diabetes symptoms have creeped into you. So people just scan this, take the retinopathy, retina images, and then they determine whether you have diabetes or not. That's one thing. Second thing is when you have, say, sunflower field, there'll be a lot of sunflowers. People have built a lot of applications wherein when you have sunflowers like that, you can just take a photo of this sunflower field and then determine what is the yield. It will automatically count how many sunflowers you have. Simple. You can in fact take a video, split the video into multiple frames of images, and job done. Okay, this is something which people do. And you apply these kind of filters which will automatically determine how many sunflowers are there because it's in this shape, circular shape. Anything, any image which has these circular shapes, etc., you can identify, kind of, yeah. Now, let us understand on how do we deal with noisy images. One way to remove noise is by taking a Gaussian. This is something that we have discussed, right? If I have noise in the image, then you take a Gaussian filter and apply that. Okay, that's wonderful. So if I have noise in the image in this way, for example, this is, say, your original image, then you have salt and pepper noise. Salt and pepper noise means you'll have white spots like salt and pepper black. So you'll have white and black spots. That's salt and pepper noise. Then you can also have impulse noise. Impulse noise means just having those white dots is impulse noise. Then Gaussian noise. Gaussian noise means 0 means black and 255 means white, right? So anywhere in between you take the values, and then if say 240 or 50 or whatever be the values, if you have those kind of spots, it's called as Gaussian noise. Okay, now if you apply a 3 by 3 Gaussian filter on the image, salt and pepper noise image, this is how it appears. If you increase the filter size from 3 by 3 to 5 by 5, 5 by 5, then the amount of blur increases. It will smoothen it even more. And if you use a 7 by 7 filter, it will further smoothen. But the disadvantage here is that, okay, a clear disadvantage here is that your image is becoming blur. Okay, your image is becoming very blur. Since your image is becoming so very blur, you'll have to take an action. What action do you take? You cannot apply this a Gaussian filter when you have noisy images. It's not, it's just a basic way of dealing with the noisy images. So people proceed further with non-linear filters such as median filter. So what happens? Let us understand. When you have noisy images, say you have an image like this, and here there is no noise in this patch. If you're, this is an input image. On that input image, if you take a 3 by 3 filter and apply this 3 by 3 filter on this patch, it doesn't make any difference even if it's median, because there are no outliers per se. You take all these values 10, 11, 10, 9, 10, 11, then 10, 9, 10. Take all those values. Now, even before you calculate median, you need to first sort the data in ascending order or descending order, and then take the middle value, and that would be here. Yeah, the same number is coming up. That's fine. Then move your patch, 3 by 3 patch or filter, one stride. One stride means one pixel. When you move it one stride in this way, you take all those numbers, and here you have outliers 0, 0, 1 are clearly outliers in comparison to the other numbers. You sequence them, and once you sequence them, you take the middlemost value, which is 10. So you replace this with 10. Here also there is no big difference. However, now you will have a difference. So you have been moving your, say you have been moving your filter across your image, and you reach the final patch here. When you take all those numbers here, very clearly it is an outlier, 99. So when you take all these values, when you sort them in a sequence, and when you take the middle value, it becomes 10. So 99 has changed to 10. So this 99 could be a, an outlier. It could be a patch which appears, or a dot which appears on the image, that can easily be gotten rid of. And if I apply such a filter, look at the difference. If you apply Gaussian, the noise is not going away completely, and also the images are becoming a lot blur. But when you look at the median filter here, and when you apply on the images, the these dots are gone, and then it appears a lot more smoother. Okay, and similar to that, there is something called as alpha trimmed mean. So if you take alpha as 5%, just as an example, so what it does is, say you're applying your filter on this patch, you take all these values, sort them in a sequence, you'll have all those values, say you have 9 or whatever be it. Then you remove the bottom 5% and the top 5% after sorting them in a sequence. So you sort them, and the assumption is that the bottom 5% and the top 5% values would be like zeros and 255s, will be extremely large. So you kind of get rid of those values. Okay, this is what we do, what people do. Okay, so this is also another thing. And we also have bilateral filtering. Bilateral filtering, what it does is, it takes your image and creates an animated version of your image. Okay, it takes your image and just comes up with this animated version of your image. This is called as bilateral filtering. This is called as non-linear filter. It will smoothen your image by preserving your edges. Wherever your edges, it will not get rid of those edges. This is bilateral filtering. Okay. Another very good edge detector technique that exists is called as Canny edge detector. So just to do a quick recap before you forget about what all we discussed, let me show you this. So these are the filters that we have discussed. Okay, we have discussed about edge detectors, wherein we have Sobel, Prevet, Roberts, Canny. All of these are the various edge detector techniques. Now we are discussing about Canny edge detector, and we have also discussed about Laplacian filter. We also have a blob detection algorithm or a filter which is called as Laplacian of Gaussian. Any circular shapes it can identify. And then you also have nonlinear filter wherein you have bilateral filter. Of course, all these things we will practically do it. Okay, do not assume that this is only theory. No, we will practically implement each of these using OpenCV. Okay. There are three important features which should exist in a good edge detector. First, any good detection technique should respond to edges and not noise. Sometimes you'll have noise in your data, and you don't want your algorithm obviously to respond to uh, noise. You want your filter to respond only to edges. Wherever there is an edge, you want your filter to detect that. Okay, and then there is some good localization. That means your filter should help you detect an edge with good localization. That means detect the edge near the true edge. Wherever there is an edge, you need to detect that. Wherever there's a non-edge by mistake, you should not detect that. Okay. And then it should have a single response. One per edge. Single response. It should not be like this. If I draw like this and if I say, okay, this is the edge, then you should, I mean, that's not right. There should be a single edge, not bunch of edges. Okay. Now let us take this input image and let us solve this. You take an input image and then you apply a Sobel along x-axis. Then you apply a Sobel along y-axis. We already discussed about Sobel edge detector, right? If I move along the x-axis, what kind of edge will your model detect? Let me ask this as a poll question. If I move along the x, or if I apply Sobel along x-axis, what edge will it detect? Let me see. So a new poll question. If we apply Sobel filter along x-axis, then what edge will the filter detect? Okay, would it be vertical or will it be horizontal? Please, can you answer this? Wonderful. 90%. Oh, the count is dropping to 80%. But then again, I think a few of the people are trying to push it hard towards the higher percentage. Yep, you guys are right in saying that. I would say 85, right? I think that, yeah, touch 85, please. 84. 85. Good. I'll quickly escape from there before the count drops. Yep, you're right. If you're moving along the x-axis, you're moving in this way. When you're moving in this way, you clearly see that there is an edge over there. Okay, there is an edge here. And that's the edge that you're seeing here. Okay, that's the edge that you're seeing there. Okay, so that's how it is basically. So when you move along this, when you move along the y-axis in this way, then this edge is not visible because when you move in this direction, there is no change along this. So there is no edge here. It doesn't appear. So if you want to find all the relevant edges, then you have to actually apply both Sobel along x and Sobel along y-axis. But then, can I at one go identify the edges both along x and y direction? Yes, that is called as Canny edge detector. But then all it does is it is going to apply individually Sobel along x and Sobel along y direction, and then it is going to combine these two. This is the symbol for gradient, rate of change. So how do you combine in this way? You're finding the magnitude of rate of change, and you're combining the rate of change along x and also along y direction, and then you square it and take the square root of that, right? When you square it and take a square root of that, then this is how it appears. And when you find this gradient, take that gradient and say if that gradient is greater than or equal to threshold, then what happens? Okay, if that gradient is greater than or equal to threshold, you're getting a value which is, this threshold is empirical. Okay, let me write it down. Meaning there is no defined rule on what should this threshold value be. It keeps changing. Okay, the threshold value keeps changing. It won't be the same. Okay. If this threshold value is, say, 25, what do you mean by that? If the rate of change here, only if it is greater than or equal to 25, you'll get some number. If it is greater than 25, only consider those kind of changes. If the rate of change is very less, okay, then do not consider. For example, if the rate of change is say 20 or 18, that means the rate of change is so less. The rate of change, if you're moving along, here, if the rate of change is very less here, it shouldn't be detected. You don't want such a small change to appear. Only if the change is significant or greater than 25, you proceed further. This 25 is a number which is empirical. There is no defined thumb rule on how to choose that. You can choose. It depends on the application that you're working with. If you're working on a, say, radiology image, cancer prediction, then even a small change matters. So maybe you'll reduce the threshold to 10 or maybe to 5. Who knows? Right? But if you're working on social sciences kind of a project, like typical projects that you do, then you need not have such a low threshold. Right? That's one thing. So you first apply Sobel along x and Sobel along y. Okay, you do that. And then you find the gradient, rate of change, by combining those two. And this is the image that you get. And here what you do is you apply a threshold saying that only if the changes are greater than something, consider that. Otherwise, do not consider. When you do that, every change which is pixel value, which is black, goes away, dead black, and then this is the kind of image that you get from that. There is again a disadvantage here. What did we talk here in this? There has to be a single response. That means you need to have a single edge. But if you look at this image, and if you look at this portion, yeah, if I were to put it here, it's appearing like this. We want a single edge. We don't want it in that way. Then how do I fix it? Then your computer vision experts sat down, thought a lot, and then they thought, okay, we can fix it. And then they came up with a concept called as non-maximum suppression. Okay, they came up with this logic called as non-max suppression. What is this non-max suppression technique? Okay, so here, this is the thick rate of change. This is a thick rate of change that you are observing here. Then what happens is, you take a value, a number here, okay, and then this you call it as x comma y, and then take one number which is ahead like this, which is x prime y prime. Then you take another number behind this, which is x double prime y double prime. And then now look at this. Look at, is the rate of change at this x comma y greater than the rate of change at this point, which is a new point? That is one thing. Second, is this rate of change at x comma y also greater than this number? So if the rate of change here is more than one which is ahead, one which is behind, then this is the winner, right? This is like winning on this, and this is also winning on this. So if this is greater than this, and if this is also greater than this, then the end result would be this. Correct. Otherwise, you say it is zero. I mean, you have to proceed further. I'll repeat. Then what happens is, you say your point is here, then you take one point here, take another point here. If the rate of change here is greater than this, and the rate of change here is greater than this, then this is the winner, the one which is in the middle. It's like first, second, third positions, right? If one is greater than this and this, only then it'll be in a first position, right? So only then you take that as the true edge. Otherwise, you say, hey, that is not the true edge, and then you move on again. Again, how do you move on? Say you were here, you took one point here and one point behind. Now what you do is, say this point is greater than this. So what do? You take another point here. Okay. And then once again do the same thing. Check whether the rate of change here is greater than this and this. If yes, this is the edge. Otherwise not. And then this, you do that throughout the image like this. Throughout the image. And then take throughout the image, and then throughout that keep doing the same task, and then keep identifying the point where you have a maximum change, and then apply that non-maximum suppression. The moment you apply, you take the image, this image is this. That means you take an image, find the Sobel along x, find the Sobel along y. It will find the edges along x, along y, combine those two. Okay. And then do a non-maximum suppression. Once you do a non-maximum suppression, Look at that here. You have the thick edge, but it has become a thin edge. After that, apply the threshold. If the values are greater than 25, greater than or equal to 25, only consider those. So you'll get an image like this. But there's again a problem here. As opposed to this image, or as opposed to this image, look at here, it's not so noisy. Here also, it's not that noisy. But when you look at this, it's looking very, very noisy. These edges are all like hanging threads, right? A lot of spurious edges exist in comparison to this, right? In comparison to this has a lot of spurious edges. This will make our life very difficult in identifying the edges. Hence, against your, computer vision experts are taken aback because there is again a roadblock. Again, they sat, again they thought on how to solve, and they came up with yet another technique called as hysteresis thresholding. What did they do in hysteresis thresholding? They took all these edges, all these spurious edges, and they formed a rule saying that I'm going to come up with a lower threshold and upper threshold only if your edge, whatever are those edges, if they are crossing the high, I'm going to treat this as an edge. If something doesn't cross the high, I'm going to treat this as non-edge. The moment you treat in this way, what happens is all these hanging threads kind of things will be gone. And there's one more thing, which is if there is anything which is below low, obviously it is non-edge. But then if something falls in between high and low like this, but then if this edge connects with another edge which crosses the high, then this will also be considered as an edge. Okay, if something is like this, just falling in between high or low or high, or something which is not crossing high, but if it goes and connects with another edge which actually crosses the high, then you start treating that as an edge. Okay, so here, if the gradient at a pixel is above high, you straight away say that it is an edge. If the gradient is below low, you say that it's a non-edge pixel. If the gradient is between high and low, then declare it as an edge if and only if it is connected to another edge pixel directly or via pixels between high and low. Right? These are the three rules that people came up. And again, this is a heuristic. Right? Again, this is a heuristic or empirical values, meaning to keep changing this value and this value, keep checking your results. Wherever you get a best result, you choose that. Okay, so here I'll give you steps on what we have done exactly. So let me choose a white screen. Let me write it down. Number one, take an image and apply Sobel along x-axis and apply Sobel edge detector along y-axis. Then combine these two. Combine the change along x and change along y. How do you combine it? You just say magnitude of change is equal to change along x plus change along y. Of course, you square, so you also take a square root of that. Then, since there might be thick edges, To get rid of that, you apply non-maximum suppression. Something, if some change is not maximum, then suppress it. Suppress changes which are not maximum. That's called as norm. This will give you a thin edge. From thick edge, you get a thin edge. Then once you get this, what do? You are now going to get another problem, which is spurious edges like hanging threads. How do you get rid of that? By applying hysteresis thresholding. Here you need to provide a value high and low. This is empirically chosen. And finally, after all these things, you put a threshold greater than or equal to some number, for example, 25. And then finally, you get an image with edges. And this image with edges is taken for further processing. Okay, perform further processing. Whatever you want. Maybe you want to use this image for prediction purpose. Do it. It'll be faster, easier. It will take less memory. All these other advantages that exist. The next thing that we have is okay, sorry about that. So the next thing that we have is this image sampling and interpolation technique. So image sampling and interpolation technique is very, very important in terms of reducing the size of the image or in terms of increasing the size of the image. Usually image sampling is related with subsampling. This is correlated with subsampling or reducing the size. Interpolation is usually correlated with making your image bigger from the given size. So question to you all is, if this image is very big, how do I reduce the size of the image to half? How can I generate an image which has half the size of this original image? Can someone answer this? Can anyone answer? I give you an image, and if I say that make the image half the size, how would you do that? Quickly. I request everyone, just think out aloud, give some exercise to your brain, and can you do this? Let's see how many of y'all will get it right. Okay. Simple, friends. You remove every alternate row and column. So if you have this image which is of size say 28 by 28 or maybe 28 by 38, something on these lines, what you do is you remove every alternate row and every alternate column. So this will become 19 by 14. It will become 19 by 14 basically, right? And then if you have an output image which you get here, if you are going to reduce this even further, and if you remove every alternate row and column again, this image becomes 1 by 4th. And on this image, if you once again remove every alternate row and column, it will become 1 by 8th the size. And now, if I keep reducing the image in that way, and all these reduced sizes, if I zoom to map this, so now if I just maximize this in this way, okay, and if I make this image also as bigger as this image, then let's see how it appears. Look at that. There's a lot of craftiness, meaning it's all a lot blur. Okay, you're reducing it to half, then you're reducing it to 1 by 4th, and you're reducing it to 1 by 8th. But then when you zoom it back to this size, look at that, a lot of meaningful information is gone, lost from your image. Since a lot of meaningful information is lost from your image, this is not the right way to reduce the size of the image. Okay, so we have to look at something called as image subsampling. Very, very important. If you do not sample the image properly, you'll get these kind of things, which is called as aliasing effect. Aliasing effect means when you have an image, but you're reducing the size of image, but you're not maintaining the subsampling logic. Okay, so look at this portion, the upper portion of this. It all becomes okay a lot more. This portion, if you observe, it's becoming a lot, you know, it's losing the shape basically. This is called as aliasing effect. Here also you have that aliasing effect. It's like that. The image is not proper. Here also the image is not proper. You're getting a different shape altogether. So to counter that, people have come up with a concept called as Nyquist rate. Okay, Nyquist rate or Shannon's sampling theorem. Nyquist rate or Shannon sampling theorem says that whenever you take a sample or whenever you reduce the size of the image, ensure that the reduced size is greater than or equal to 2 times of maximum frequency change. Hey, what does that mean? I'm lost. Don't worry. I'm here to walk you guys through. Do not worry. Let's understand. Say you have an image like this. Okay. What does Nyquist rate say? The minimum sampling frequency that you choose should be greater than or equal to 2 times of maximum frequency change. If you take this portion of the image, if you take this portion of an image, you have one maximum change from black to white. Here is where you find that change from black to white. So maximum change is 1. So sampling frequency should be greater than or equal to 2. 2 times of 1 is 2. And here what you're doing is you're choosing 4, in total 8, right? You're choosing 4 points here and you're choosing 4 points here. 4 plus 4 is 8. This 8 is obviously greater than or equal to 2. So this is a good sampling strategy. Let us look at this image. Here also you have this change. You have one change, which is maximum change from black to white. There's one maximum change. So sampling frequency should be greater than or equal to 2 times of maximum frequency change. So it should be greater than or equal to 2. Since it is greater than or equal to 2, and here you should have minimum 2. Here you have 1, here you have another. Okay. So here you have 1 and here you have 1. So you have 2. This 2 is greater than or equal to 2. Since it's equal to 2, you choose that. Okay. Then you have another value here. Here there is a rate of change from white to black. Okay. And here you have one value and here also you have another value. So you're choosing 2, at least 2. Should be greater than or equal to 2 times of maximum frequency change is only 1. Right? So this is also a good sampling strategy. How about these two? Let's see. So if you observe this, there is one change from black to white. So the maximum change is 1. 2 into 1 is 2. So minimum frequency, sampling frequency that you're going to choose should be at least 2. But here you're choosing only 1 in this. So it's a bad sampling strategy. Same is the case with this also. Here it is fine, but here it's not fine. And here it is not fine. So because here you're choosing 2, that's fine. But then when you look at this patch, you're choosing only 1. It should be minimum 2 because the maximum frequency change from white to black is 1. Okay. This is called as Shannon's sampling theorem or Nyquist rate. And we have to fix to that. Another thing is called as wagon wheel effect. So let me show you a video. Let me play a video so that it starts making sense. There is this falling helicopter illusion, or yeah, this one. Okay, if you look at this, or maybe this one, you look at that, and it is giving you an illusion as if this helicopter is just flying like that. Okay, without the wings rotating, right? You're getting that illusion basically. Even when you look at your fan, ceiling fan, sometimes you get that kind of an illusion. Right? Why is a question. Because of something called as wagon wheel effect. What happens in wagon wheel effect is that, you know, at the blink of an eye, if this is your wheel, okay, I can also show you that, you'll get an illusion as if your wheel is rotating in the reverse direction, right? Let me show you that. Okay, let me go here again. Our wheel reverse illusion. You might get a sense that the wheels appear as if they are rotating in a reverse direction. Which one should I play is what I'm thinking. Yeah, let's see this one. Yeah, look at this wheel here. The feeling as if it's not rotating, or sometimes you might get an illusion that it's rotating in the reverse direction. Reverse. So that's fine. So why do you get such an illusion? Is a question. Because of something called as wagon wheel effect. Your eye, human eye, will blink sometimes, right? And we blink at a certain speed. And when you're traveling at a rapid pace, what happens is When you close your eye, your wheel would have moved here, then moved here, and then maybe it is here. Within one blink of an eye. So you are watching this. The moment you blink, okay, the moment you blink your eye, that means you open and close your eye, you'll find as if your wheel point is here. Okay, and a blink of an eye, you'll feel as if you're here. So what illusion you'll get? First you're seeing this, next you're seeing this. You missed out this, this, and this. This moment you missed out, and you're seeing this. So you'll feel as if after this you're getting here. So you'll feel as if the wheel is rotating backwards, counterclockwise. Okay, this is the kind of illusion that you get. Okay, so these are two things that you need to remember: Nyquist sampling rate, and also this wagon wheel effect. Now let's take this image. We discussed that when you subsample, meaning when you reduce the size, or when you downsample, all mean the same. Downsampling, subsampling mean the same. When you do that, you first need to apply your Gaussian filter. Means what? You take your image. See that somewhere here? Yeah. First, I'll explain this and come back. You take your image. Okay. You first apply a Gaussian filter on the image. Then subsample. Then again apply a Gaussian filter. If you want to again subsample. Again subsample. Again take your image. You apply a Gaussian. And again you subsample. Keep doing it. When you keep doing it, the beauty is that you'll have something called as Gaussian pyramid. I'll give you a practical application here. Say you're using Facebook. On Facebook, say you uploaded your photo, uploaded your team outing photo. And your Facebook gives you an option to automatically tag your friends. Tag your friends. Meaning, say you're uploading a photo, group photo, wherein you also have my image. So here you are there, here I am there, and all that. So what Facebook does is, Facebook is going to look at, if this is you, it's going to look at all of your friends. It will quickly look at what kind of profile pictures your friends have. Okay, and say you have a close-up image. This is me, you and me. This me is my face, which is a close-up image. So this will have a bigger size as opposed to this. This will be very small. If you want to just crop the face, this is very big. Then how do I do a mapping? When I take this and try to apply here, this will be a big patch, big patch. But then this image is having a small patch. So how do I map it? We can map it. If you have Gaussian pyramid, wherein I have image, this is my image. I'll subsample, 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 so on and so forth, until it becomes small. And this, when I apply here, there can be a match. If I apply big images here, I cannot find out. But if I can apply, say, this patch, maybe, it will identify the image. In these kind of scenarios, you need Gaussian pre-filtering. So you apply Gaussian, subsample, apply Gaussian, subsample, apply Gaussian, subsample, in this way. Don't directly do it. Don't directly do it. Apply Gaussian, subsample, apply Gaussian, subsample. Okay. Now when you subsample in that way, and when you zoom your image, this is how it's going to appear. But when you do not do that, it will look like this, very, very crafty. Take this simple example of a text. Say you're scanning the text and then you want to automatically enter that into your database. You don't have time and energy to type it. Okay, and we have done a project for State Bank of India wherein you have your loan application, right? When you fill your loan application, you enter the details such as name, address, gender, phone number, email ID, all that. Now, what usually happens is the people who collect the application form from you, they will come back and enter all these details in a database. Okay, they enter all these details in a database. Manually, they do it. This is called as brain drain, underutilization of human potential. Why do you do this when you can automate this? So what people usually do is they scan this, they apply these kind of algorithms, and automatically they put that in the database. They automate these tasks. That is exactly what we have done. Of course, we have used something called as horizontal projections and vertical projections, but then this is how exactly they do. At that point of time, you should actually, if you directly do a subsampling, this is how it would appear. I mean, there is nothing which is visible. But then if you apply Gaussian, okay, if you apply a Gaussian filter, this is how it will be. And on that, you do a subsampling. And then you get this. Okay, that's how it will be. This is an anti-aliasing effect. Look at this and look at this. You're having all those patches, yeah? Okay, so that's how you build a pyramid of images, and you can use it for satellite imagery that you get. Just that you keep reducing the size of the image. Apply Gaussian, subsample, apply Gaussian, subsample, apply Gaussian, subsample. Keep doing that. And it's easier for image recognition. So one more quick thing that we will discuss before we before we take a break, because after the break I want to get started with hands-on. Okay, hands-on exercise. So please pay attention here. If you are given a big image, how do you downsample it? We have looked at it. Apply Gaussian, subsample, apply Gaussian, subsample. Keep doing that. But then if you have a smaller image and if you want to make it 10 times bigger, what would you do? One simplest way is, if you have say 5 by 5, then repeat each row and column say 10 times. Take each row, repeat it 10 times. Take each column, repeat it 10 times. That would make your image 10 times bigger. Okay, but that's not the best way out. So we have a few image interpolation techniques such as nearest neighbor interpolation. So let me explain that using this. Nearest neighbor, linear interpolation, you have bilinear interpolation and bicubic interpolation, etc. With that we will end, but then let's understand this. So here, linear interpolation means, say you have an image like this. That's a 2 by 2 image. Okay, you want to make it, you want to enlarge it. So that means you want to add an additional row and an additional column. In that case, what do? You need to add, say here, one value. Okay, so what you do is you take this and this. You take one value here, which is this one, and you take one value towards the right, which is this one, this part, and then find out how far away is this pixel from this and how far away is this pixel from this central pixel, and then simply multiply. That's it. So if you want this pixel value, if you want this pixel value here, all you're doing is you're saying 1 minus a into the pixel which is towards the left, this one, plus a into the pixel value which is towards the right. That's it. The moment you could do it, issue is solved. And if a equal to 0.5, meaning you'll have this equidistant. So 0.5 into this plus 1 minus 0.5 into this. So that means you're giving equal weightage to the pixel which is on the left side and the pixel which is on the right side. And whatever value you get, that will be this new pixel. Same is the case with this also. If you want to fill something here, you take 1 pixel towards the left, take 1 pixel towards the right, and then solve it. If you say a equal to 0.5, you're giving equal weightage to the pixel on the left, equal weightage to the pixel on the right. That's it. You apply it and you get the central pixel value. If this pixel value is 10, if this pixel value is 20, so 0.5 into 10 plus 0.5 into 20, which will be 15, you replace that with this. That's it. Simple. For this also do the same thing. If you want the pixel value here, then first do it in this way, right? So what do you do? First, you need to find this pixel. Let me put that in pink color. First, you need this pixel value, this pink color box. Okay, to get that, what do? You take 1 pixel towards the left, 1 pixel towards the right in this direction. So that is this and this value. So do 0.5 into this plus 0.5 into this, 0.5 into this plus 0.5 into this. Whatever you get, you'll get here. Then you have to find this pink pixel value. Once again, do the same thing, wherein you do 0.5 into this plus 0.5 into that, you get the central pixel. Once you get these two, finally you once again apply in order to get this central pixel. 0.5 into this plus 0.5 into this will give you the central pixel. This is called as linear interpolation. Then you also have bilinear interpolation. Bilinear interpolation means if you want to find a pixel value here, you take all the 4 bordering values. In linear, what did we do? If you want a pixel, take 1 pixel towards the left, 1 pixel towards the right. 0.5 into this plus 0.5 into that will be the central pixel. But in bilinear, you consider all the bordering pixels. So if you want this pixel, look at this pixel, this, and this. And you solve it. If this is I comma j, then it's, you write it in this way, 1 minus a into 1 minus b into this, plus if you want this, it will be a into 1 minus b into this function of this, plus if you want this is like a comma b, a into b into this, and if you want this part, it'll be 1 minus a b into this. I mean, this math is very trivial, okay? And then you also have bicubic interpolation. Okay, just to do a quick recap, or we will take a break and then I'll do a recap and then we'll proceed further because it's 12:40. I think it makes sense for us to take a quick 10 minutes break and let's come back. I will do a recap and then we will do uh, all these things that we have discussed using OpenCV. Okay, let's take a quick break and come back. All right, so let us proceed further and take this discussion further. So we need to first discuss about, or let us do a quick recap. First, we discussed about edge detection filters. As part of edge detection filters, okay, we discussed about a lot of filters, but then Canny edge detector is one amazing edge detection filter. Okay. Apart from that, you also have Sobel, we have Privet, and we have Roberts. Okay, and then we discussed about Canny edge detector. Next, we switched gears to image subsampling or downsampling. And we have also looked at upsampling. In upsampling, it is called as interpolation. In interpolation, we have linear interpolation, bilinear interpolation, and we have bicubic or cubic interpolation. Okay, and now what we shall do is I'm going to resort to Python, and we are going to solve, or we are going to do this OpenCV stuff. For this, I need to get the OpenCV program code, and we are going to use this. So here we have the data. Okay, and we have covered until here wherein we split the data. Okay, now we will do a lot of transformations on the images. Okay, a few of them will be a lot of fun. A few of them will be extremely important for us to proceed further. Okay, and then we will discuss about various things. Today, I think I need to also enable the webcam. And then I need to show you something very, very interesting. So we'll look at image translation, and that's the first thing that we're going to look at. In this image translation, what we are going to do is we will again same thing, we will import. I'll first let me remove everything so that I free up the memory. I'm importing CV2 and I'm importing numpy as np. Then you have cv2.imageRead. Okay, so we want to read the image. Let me read that image if this exists. Wonderful. So the image is of 256 by 256 by 3. 3 means it has 3 channels, 3 color channels. 256 rows, 256 columns, and 3 color channels. Okay, and then if you do this, wherein say image.shape colon 2. Okay, colon 2 means 0, 1, and 2. You're taking 0, which is 256. Here again you have 1, which is 256, and 2 here is 3 channels. Okay, you have number of rows and number of columns. I'll run it. So you have number of rows, which is 256, and number of columns, which is 256. And then you're doing some translation. This translation matrix or transformation matrix is as follows. You have 1001, and 1001 is called as identity matrix. You see 1001, it's called as identity matrix. This component means take the image as is, identity matrix, and then you have a translation along x and translation along y direction. Okay, translation along x is 70 and translation along y is 110, 110. So we have translation along x. You are moving along x, that is, you are moving along x in this direction, right direction. When you say translation along y, you'll be moving along the downward direction. Once we create a matrix like this, okay, you put that into something called as translation matrix here, and then you do cv2 dot warp affine. So once we create a matrix, we use the function warp affine to apply it on the image. So you have an image and you apply a translation matrix on it. And when you apply a translation matrix, there is also another argument, or these are called as flags, FLAG. Okay, in this third flag, basically, or here, what you're giving is, sorry, this is not a flag, this is an argument, my bad. Okay, this is an argument that you have. So you're saying I want number of rows and columns as that of the original image, and then cv2 dot interlinear. This is interpolation flag. Interpolation flag. And you're doing an interpolation here. Okay. So what would happen? Let us see. So you're taking an image, applying a translation matrix, and you're saying, I want the window size to be similar to the original image. If the original image is like this, you want the window size of the output image also to be the same, and you want to do linear interpolation. And then you say cv2.image show. In that you want translation. Okay, the window name should be translation, and within that you want this translated image. Let me run it. There we go. So you knew on how our original image was, right? So you're ensuring that whatever size you have, this is also of the same size, but then you're trying to move it 70 pixels towards the right and 110 pixels towards the bottom down, and then you have your image. Now there is yet another translation. What are we doing here? I'm saying that, okay, since this image is getting just cut there, it's getting disconnected there, kind of, you're not able to see the complete thing. So if I were to see the complete image, what I will do is I'm going to extend this. In the output that you're seeing, I want to extend the number of columns by 70, because you have 70, I want to extend it by 70 here. And here you have 110, so I want to extend it by 110. Okay, the same thing again. I'm importing CV2 and NumPy. I'm reading the image using CV2.ImageRead. Then I'm saying number of rows and number of columns is equal to image.shape of 2. Means what are you doing? Image has a shape. Image has a shape of 256 by 256 by 3. This 256 has index number 0, this has index number 1, and this has index number 2. If you say colon 2, all you're saying is you want 0 and 1. Whatever comes here, that is ignored. Okay. 0 means 256, 1 means 256. Okay. Take those many rows and those many columns here. And you load it. So CV2, NumPy, this, and this. Then what we are saying, NumPy dot float. You are now creating a translation matrix. And as we have already seen, translation matrix will have 1, 0, 0, 1, and 70 and 110. So it's 1, 0, 0, 1, translation along X and translation along Y. Translation along X is 70, translation along Y is 110. You have it. You run it. And then you say CV2 dot warp affine, take the image, the size of the window of the output that you see is this size, then number of columns plus 10 and number of columns plus 110. Run it. And then you see the image. Okay, so you have the image here. So it came, right? Your box size ideally would have been like this. But what you're doing is you extend it by 70 pixels here. You extend it by 110 pixels here. And this is how you get. Now you can even further extend the image, the window size. You can say, okay, this time let me do one thing. The number of pixels along the columns, I want to extend it by, if your original size of the image is so much. When you displayed the image, it was appearing like this, only in this portion. So you increase by 70 and 110 so that the entire image was visible in the window. This was the window size. Now you are again extending this by 30 and 50 so that the window size in which you see the image further extends. CV2.warp-affine. Warp-affine is a function that you use whenever you want to apply any kind of transformations, like the translation that we are using. Any kind of other transformations can be applied. For that, you have to use CV2.warp-affine. When you run it, why is it going in this way? This is not the right thing. Okay, now I get it. So why that problem is arising is because I should have run this code also. Okay, we need to import the new image. Otherwise, it will take only that old image and do it. Why? Okay. Sorry, let me restart this. Okay, now let me run this once again. Mhm. 1 second, let me run it. CV2, NumPy, read the image. Okay, number of rows, columns. You have a translation matrix. You're applying it, and then you want to view this image translation of translation. Yep. Yeah, here we go. Right. This is the kind of I don't know. Okay, sorry, my bad. Again, I've run this border pixel wrap. What's going wrong with me? Okay, so sorry. Let me run these once again. Importing the files, loading the image, number of rows and number of pixels have been taken. And it's 256 and 256. Here we have the translation matrix. And I'm applying a warp affine. This, I'm taking the input image. And then we are applying the translation matrix. Let me store it here so that I do not get confused. All right. So we're saying image translation matrix, and we are just extending the window size further, and then you can view the image. Now I think things should be fine. Yeah. Ideally, this is not the image that you should see. Sometimes your system is pretty tricky. That it happens, most of the times. Let me restart the kernel. The window is gone. It happens most of the times because it saves the previous images in memory. The moment it saves the previous images in memory, it throws these kind of issues at you. That's fine. It's part and parcel of the programming. You will have to any which ways live with it. Now, there we go. This is the right one which we wanted to see. So what we have applied is we translated the image 70 pixels towards the right and 110 pixels towards the in the downward direction. But then what you're doing is here you're saying number of columns. If I keep it as is as the original stuff, it would get cut and you'll be able to see only this portion. So what we have done is we have added 70 pixels. So whatever you're moving by 70 pixels, you're adding those many pixels on this side. So the entire image would be visible on this side. Since you're taking it down by 110, you also want to add 110 rows here. Okay. And then you're adding another 30 here. And you're adding another 50 here. So this becomes big. Right? This is what we have done. And one more thing is, when you have those border pixels, what do you do with that? Say I'm translating the image by 70 and 110. Okay. If you just do a translation, what would happen is you will be moving your image 10 pixels or 70 pixels towards the right and 110 pixels downwards. And you're saying now that I want to apply this translation, whatever is being applied on the image. And then I want to take this image and then apply this translation matrix on that image and the resultant. So this is your input image that you have taken. You're applying this operation and then you have an output image. This output image, you want to display it in a window size, which is similar to your original image. Your original image, if it is 256 by 256, you want to use the same window size to display your image. And here you're applying linear interpolation for the missing pixels. Okay, and you want to do a border. You want to do a warp affine. Okay, so you're doing a border wrapping. Sorry, not warp affine. You're doing a border wrapping. We discussed about the border pixels issue, right? Bordering effects. How do you handle this bordering effect? You do clamping, you do wrapping, all that. So we are trying to do this wrapping. And one means you want to take one pixel and move it throughout. So let me run it and then explain it once again. Yep. So what is happening here is the window size will be the same. You're moving your image by 70 towards the right and 110 downwards. Okay, and then what's happening? You're doing an interpolation and you're having a border wrapping. So you take the last pixel, you move it throughout. You take the last pixel, you move it throughout. You take the last pixel and move it throughout. Okay, and then here. We can also rotate the image. There is also something called as image rotation. How does this work out? Okay, image rotation means you want to take what you're doing is you're importing the required libraries and you're loading the image using cv2.image read and you're giving the complete path of the image and you're loading that. So let me run the first three lines. Then you're going to your image dot shape, which will give you 256 by 256 by 3. You're just taking 256 and 256. Index number 0 and index number 1, and you're storing it in number of rows and number of columns. Then you're applying this function called as get rotation matrix of 2D. You're saying get rotation matrix 2D, wherein you're saying take the number of columns by 2 and number of rows by 2. So if your image is this, if you say number of columns by 2, you count all the number of columns, and if you divide it by 2, you'll get at the center. If you say number of rows by 2, you take all the rows and divide it by 2, so you get to the center. So you'll get to this middle point, okay, because you're taking number of rows by 2 and number of columns by 2. And then you're using 30. This 30 means shrink the image by 30%. Shrink the image by 30%. Make it small by 30% from all angles. If this is your image, reduce from all the angles and then make it shrink by 30%. Okay. So by 10%, 20%, 30%, shrink it. And then what you do is, sorry, my bad. Okay. This 0.7 means that you want to shrink it by 30%. Okay. That means you want only 70% of your image. Okay. You want only 70% of your image. Okay. That is the meaning of this shrinkage. Sorry. This 30 here that you're seeing is a rotation. By what angle do you want to rotate? And here you're saying that you want to rotate this by 30%. So you have this rotation matrix, cos theta, minus sine theta, and cos theta. Okay. You'll have the rotation in that way. And you're saying you want to rotate the image by 30 degrees. And it will rotate the image counterclockwise. Counterclock, not clockwise, not in, if your image is like this, you want to rotate by 30 degrees, not like this, but you want to rotate it like this, counterclockwise. So if I were to run this, let's see what happens. So you're getting that rotation matrix in place, and then you're saying cv2.warp affine. You take the image, apply the rotation matrix, and ensure that the output image has the same number of columns and rows. There we go. Run it here. Yeah, this is how it's going to be. So you take the center and then you rotate it counterclockwise, anti-clockwise by 30 degrees and shrink, make your image smaller by 30%. So only you have 70% or 0.7 of the image. This is another thing. Then there are multiple ways of rotating your image. Okay, all these are those different ways of rotating your image basically. You can do the translation and rotation at the same time. So what you're doing here is you're taking translation matrix, you're doing the rotation of that, and then first you're applying the translation matrix, and then you're applying the rotation matrix, and then you're taking this translated image and then applying the rotation on that. So you do the translation matrix, rotation. You first apply translation and you get the output. Take this translated image and then apply the rotation on top of that. Then you have the rotated image. There we go. Translated and rotated. And you're not shrinking the image. You're taking the same size image. You're rotating it by 30 degrees counterclockwise, and then you're using it further. Okay. And this part, if you're a little confused on this part, it's very, very easy. Translation matrix. Again, it's 1001 and translation along X and translation along Y direction. So translation along X, all you're saying is take 50% of number of columns. In your original image, number of columns is 256. 50% of that, 0.5 into that would be 128. All you're saying is, let me take 1001 and 128 here. That means move your image 128 pixels on the right side, and here also you're doing the same. You're saying 0.5 into number of rows. This is rows comma columns, right? Rows, columns, both are the same, so that's fine. So you take number of rows, multiply it with 0.5, so you get 128. So move it downward by 128 pixels. So you're just moving it down in that way. Okay, that's the meaning of translation. And since you're moving it down by in this way, how it would appear your image, if your original image was like this, then it will move in this way. Hence you're saying your output image, when you do this, your output image should be twice as large as this. So what would happen then? You'll add, you're moving it 128 towards the right, so you're adding 256 here. You're moving 128 here, and then you're adding 256 here. 128, 128, 128, 128 in that way. Okay. And then final thing, we can actually resize the image. And when you resize the image, what we are trying to do here is we are using a factor. So I'm importing CV2. We are loading the image. And when you say cv2.image show, it will show you the image. And then you have a scaled image. What you're doing is you're saying cv2.resize the image. Okay, and how do you want to resize it? When I say none, the output image, none means it should be the size of the same input image, the window size. I'll show you that. And here you're increasing it by a factor of 1.2 along x and 1.2 along y, and then you're doing interpolation, which is cv2 dot interpol. So you're enlarging the image by 20% on x and y direction. Then you're doing a linear interpolation. That's a linear interpolation image that you want to see. cv2 dot image show means you want to see this scaled image, and you want to give the name of that window in which you have the image as scaling hyphen linear interpolation. Then you want to do cubic interpolation. Then you want to do area interpolation. Same thing. Let me run this. And you'll have all these images. So you have this image. Where are the other images? Let me do this. This is the original image. Then you have the scaled image. Then you have this image. Finally, you have the skewed image. Okay. So this is how the images will look like. So you have your original image, and okay, so you're taking your original image, you're increasing it by 1.2 or 20%. When you increase it by 20%, what are you doing? You're increasing the size of the image. So if I were to go back to this, what did we do here? We were discussing about this, that if you have an image and if you want to make it bigger, that's called as upsampling or interpolation. Okay, and we discussed about the various interpolation techniques. And when we do that, and when we expand this, you have to fill the additional pixels. So you're just using a linear interpolation first. Then you're also trying out something called as cubic interpolation. And if you want to make your image look very big, right, you can do this skewed size. You're just increasing the window size like this. So in this way, you can play around with your images, right? You can reduce the size or you can increase the size. Okay. All these are done using translation matrix. So I'll stop here, and a quick housekeeping things. So quickly, we have the attendance form which is placed here. Okay, and please give your feedback. Yeah, Ramesh Kannan, you can do it. You can write a loop and then do it. Okay. Yeah, we will learn that. We will learn all that, Supriya. Okay, so for now, please give your attendance. Okay, and you'll get a certificate upon your attendance. It's posted here. If you want me to post that here, I'll do that. There we go, attendance form. And here is the LinkedIn, sorry, not LinkedIn, YouTube video link. Please click on that, subscribe so that you watch the future videos. Yeah. And the quiz will be posted on our Facebook and LinkedIn. Practice it so that you will get to learn new things. All right. And a few of y'all, yeah, you need to practice, Satish. That's the only way out. You might get confused, but if you practice twice or thrice, things will fall in line because you're looking at this for the first time. That's what happens. Yeah. And then a few of y'all were asking for my profile. I'll share it with you because I don't know. A few of them were complaining that I shouldn't be sharing, but then that's okay. Few of y'all are asking, so I'll put it here. I received some personal messages, so I responded to you all personally. But if you want to connect, that's the profile. Yep. All right, friends. No, it's there. We will not provide any screenshots of code in learning management system, Rajkumar. The reason being, it's already there, recorded. Right? For example, if I open this, it is already available here, entire code. Okay, you just look at this and then you can answer. You can type it on your own. Yeah, Nagraj, you'll get it. Yeah, you first complete this, Satish, and you can reach out to me. I'll have a conversation with you to understand your understanding, and then I can share more. Okay. All right, friends. Thank you so much. Attendance link is provided on the chat window. Once again, I'm posting it. Thank you all so much. No, it won't be. It won't be. Let me know which part is blur. I will open that in the class and then show you. Yeah. Yeah. Thank you so much, Shiv Prasad. It's a pleasure. Okay. Thank you all. Okay. You just double click to expand the mind map. Yeah. Thank you all. Bye.
Hello. Friends, are you able to hear me now? Okay, perfect. Great, wonderful. Yeah, thank you. Thanks for the confirmation. Okay, let me share the screen as well. Yeah, wonderful. All right, guys. Sorry for the delay, and thank you for joining in. We had a small technical issue. We have sorted this out. Thank you for your patience. Let's start the session. Before that, right, let me welcome you all for the FDP program. We are going to deal with data science program using Python. Python programming is the go-to programming language in the space of data science, statistical analysis, AI, and it is anyways a generic programming language which is being used by all the walks of IT industry. It can be used for developing video games. It is used for developing a QA code, right? Anything can be done using this particular Python programming. So that is a small intro, friends, about the program that we are going to deal with. But before I begin, let me introduce myself. Well, this is me. My name is Sharad Chandra. I'm a data scientist, big data engineer, of course. And I have overall 15 years of experience in the space of IT. And I was part of more than 50 plus projects. And predominantly, most of them are in the space of analytics. I happen to be the director of InnoDataTix, and I'm a senior data scientist, freelancing consultant working for 360 Digit MG. This is my overall profile. So I'm coming from basically from an Oracle Corporation MNC, and later on I started with InnoDataTix, and to talk about a couple of the recent projects that we have accomplished. We have done automotive analytics to predict upfront on which component of a vehicle might go down. We also have done with HR analytics. I have worked on this extensively. We are developing a product, in fact. It's almost ready to be released. Very soon you'll be hearing about this product. We've also worked on a lot of industries like aviation sector, manufacturing sector, life sciences, healthcare, so on and so forth. And I'm, as I said, a consultant. I also work with various other institutions as well. And I also am a faculty, visiting faculty for BITS Pilani, Watson Business School, my bad. Watson Business School, and a bunch of other universities and colleges. So that's a brief intro about me. And yeah, this is my LinkedIn profile. If anybody wants to connect with me, I request you people to connect with me over my LinkedIn profile. This is my profile. Right. And this is our website, 360 Digit NG. We have a bunch of courses, including cybersecurity, the full stack developer program, which is the most demanded in the market right now. We also have RPA, Internet of Things, cloud computing, artificial intelligence, and deep learning. A lot of your colleagues are already attending our free AI session, which has commenced last week. And then we also have various other bunch of programs in the space of analytics. So that's about a brief intro about the organization. Now let me jump into the actual subject. So we are going to start with the program now. So this is the program. As I said, we will be extensively working with Python programming, and we'll also look into the data science concepts, how these concepts can be implemented using Python programming. So let me introduce you people with the data. I'm pretty sure everybody is aware of the amount of data that we are generating currently, right? Especially because of this lockdown. COVID-19 has enforced everyone to move to digital platforms. Now, when I say digital platforms, the data is getting recorded, stored, and further processed to take business advantage. And these are big players which were already doing that. For example, Facebook, LinkedIn, Google, right? Share markets, for example, e-commerce, Amazon. Object which is there on Mars rover, even that is generating data. It is studying the Mars crust on identifying whether we humans can survive on the Mars environment or not. And another very, very interesting concept which is generating a lot of data is Internet of Things, IoT. Internet of Things is a study which basically is enabling the devices to talk to other devices. It is generating a lot of data. Machine to machine communication is being enabled because of these sensors, right? And this data will be captured again and then processed further to take a informed decisions. One of such implementation we have performed in manufacturing sector to make the entire manufacturing sector production line, one of their production line, automated. So this is into food and beverage industry. They had this production line where these products were getting manufactured. Right from the filling of the bottle, blowing out of the bottle, till the packing section, everything is automated thanks to IIoT devices, Internet of Things in the industry, IIoT, Industrial Internet of Things. We will have different kind of sensors, heat sensors, vibration sensors, gas sensors, right, light sensors, etc. Using these sensors, we capture the information on the entire production line. Now, this captured information would be stored into cloud. So I'm trying to draw that cloud diagram. The entire data is pushed into the cloud. And here we do analytics. We perform a bunch of analytics. And using this information that we extracted from analytics, we take next steps. Right? Next steps will be taken here. This way, the entire production line became automated. And the good thing is, the analysis will give us reports. And these reports are real time. For example, how many bottles have blown out? How many bottles have been properly filled in with the raw ingredients? How many bottles have been labeled properly? So all this information is shown live on a television on that entire floor. So you don't need a human being to stand there and count the bottles, count the entire production. Everything is automated. And if there is any mismatch in the count, then immediately there will be an alarm raised. And that's when humans pitch in to check the problems and fine tune the production line. So this is a small project that we have implemented of late. Now, just to give you an insight, right, I'll talk about one example here. Nowadays, everybody is sporting smart watches, right? There are a lot of smart watches people sporting. These smart watches capture data, right? So they're capturing the amount of calories that we are burning, how many footsteps we take, what is the sleep that we are having. In fact, deep sleep, it will also tell how much deep sleep did we have, etc., etc. Blood pressures, right? Hydration, body hydration, etc. A lot of details are being captured by these smart devices. They're not just used for looking at the time, right? Now, what do you think, friends? If you get this data, if you have this data, can you monetize? How can you make money out of it? This is what businesses are all about, right? How can I come up with new ideas which can generate revenue for me? Yeah. Now, very easy. There are multiple ideas which are already floated, which are already successfully running. One example I can say is CureFit. How many of you have heard about CureFit brand? Mr. Hrithik Roshan is the brand ambassador for it, isn't it? They do exactly this. They take this data, they identify the relevant customers, and then they target those customers. For example, restaurants. CureFit is also into delivering food. Restaurants take advantage of this data. Now, for example, I have a very bad lifestyle. I sleep very late, I wake up early, I don't do any fitness, I eat at irregular times, right? Now, if the restaurants can learn about this information, probably they can try and target me saying that, hey, we will deliver the food to you at the right time and with the right kind of, let's say, diet program, isn't it? So they can try and market it. They can also say that, hey, if you're not having this regular lifestyle, healthy lifestyle, then you're prone to diseases. The same information can also be shared with insurance firms. Now, I would be a risky customer for the insurance firm. Now, if I'm trying to apply for insurance, medical insurance, health insurance, then insurance firm can say that, hey, you're a risk to me. So for you, there would be a very high premium charged. Compared to a person who is very healthy, he does his regular workouts, he eats at a regular intervals of time, he sleeps properly. So he is basically having a healthy lifestyle. For him, the insurance firm says that, hey, because you're not a risk to us, because you're leading a healthy lifestyle, you're not prone to diseases, we will give you discount. Not for me. I'm a risky customer, right? So if you look into this, data is the key, right? Another example, now because we are talking about this, let me also bring in another real-time example. If you have any family members or friends who are staying abroad, let's say US or Canada, in any of these Western countries which are developed, you can check with them. The vehicle insurance firms are already using this information, right? They have these apps fitted into the vehicles, on-board devices, OBDs, we call them as OBDs. And these onboard devices capture the driving behavior. Driving behavior is being captured by these devices. In fact, in India, I drive Fiat, and it has this application which has to explicitly be used. But yeah, in advanced countries, the vehicles automatically have this. And the insurance firms will get the live information from these OBD devices, of course, based on the tie-ups that they have. Now, if you are going on a trip, vacation, for example, you're going on a trip, family trip, assume, a long drive. but you were very rash while you're driving. You're changing your vehicle gears too many times. You're shifting the lanes too many times. You're driving at a very brisk speeds. So you are going to be a very risky driver. And that information is being observed by the insurance firms. And as soon as the trip is completed, you would get immediately a message saying that you were risky at this particular trip. Your points have been, right, cut off. There are certain rules they follow. If the customer is falling below certain points, then the premium is increased. At some point of time, the entire insurance premium is cancelled. They will not have any vehicle insurances. And if you were a good driver, if you are driving in the lanes at a steady speeds, not changing too many lanes, right, then you would be a good driver, right? You're not a risky person on the road. So you're less prone to commit accidents. So you will gain points in such cases. And all this is being live captured, friends. You can check with any of your friends who are there abroad. They might give you these insights. So data, again, here I'm talking about data. Data is everything, isn't it? I'm pretty sure before lockdown, everybody might have gone to brick and mortar stores and malls for purchasing different items, let's say apparels, for example. We'll go to a lifestyle or let's say Shopper Stop or any of the big malls. And we go to these, right, apparel stores. Any mall that you go, right? Including supermarkets nowadays, they are collecting the information about you. What do? They give you membership cards, right? I'm pretty sure everybody has a membership card in at least one of the superstores or any of the malls. So all they collect is, or all they do is, take your mobile number and map it to your transactions. This membership ID is nothing but mobile number. Whenever you're purchasing, whatever you're purchasing, they are getting recorded. And as a store owner, I keep collecting your data, and I will be able to identify your purchasing pattern. Data is the key again, because it is telling me about your purchasing behavior, right? Now, how do I take advantage of this? Let's say when I looked into your purchasing behavior, probably you are a customer who are purchasing only when there are offers rolled out. Otherwise, you are doing a regular shopping. There's not much, right, deviation in your regular behavior. But I observe that when there are offers, you definitely do some kind of shopping, some kind of business with that particular store. So for you, we probably come up with customized discount coupons to encourage you to purchase more. So this is called as targeted marketing. Personalized marketing is what is happening here. But out of millions of customers, if I have to target only you, then I should be able to understand what you're purchasing, how much you're purchasing for, right? When you're purchasing for, and all that customer purchasing behavior can be again extracted from data. We're talking about data science. So I'm giving you a lot of examples with respect to the advantages or the applications that we do using data. This is what is happening on internet in 1 minute, friends. Just 60 seconds of your life. So much of data is getting generated. Right? I'm pretty sure you might have seen all this already. But let me talk about it. This is one example that I always try to put to give you the insights on what exactly is happening. right? Probably the numbers may not give you that big insights, but I'll talk about YouTube because it's a pretty popular tool and everybody uses it. It is said that within this 1 minute time, that is 60 seconds of your lifetime, there is around 500 hours of videos which are getting uploaded into YouTube. In 1 minute, across the globe, people are uploading 500 hours of video. That's staggering number, right? A huge number. Now, why we need to actually look into data science, why we need to talk about machine learning, artificial intelligence? This is one of the classical example which give you the exact application, and you would be able to appreciate what AI can do for us, what data science can do for us. Now, in this example, imagine you are the employee of YouTube Friends. You're working for YouTube, assume, right? And your daily job, which is for 8 hours, is to do just one thing. Review the videos which are getting uploaded, and then classify whether the video has been loaded into the right category and right subcategory or not. That is all you have to do. Look at the video, tell whether, okay, this is into the new section. Yes, it has been properly assigned. This particular video is educational. It has to go into educational technology. Education category, technology subcategory. That is what you have to do. That's all. But if you look into the practicality of this job, you are going to see 500 hours of new video getting uploaded into YouTube in a span of 60 seconds. That means you have to work for 8 hours, 60 minutes into 60 seconds. So this is the amount of video that you have to review every day. Will that be possible humanly? Will this amount of data being processed by a human be practically possible? This is all we need to understand. Will it be practically possible? Obviously not, isn't it? So this is where we bring in data analytics, machine learning capabilities, right? ML capabilities. Training our machine, that is your computer, machine learning, right? You're giving the training so that it learns on the videos. We are going to train the computer on the videos, the YouTube videos, historical videos, of course, and they're going to tell that computer saying that, hey, if you see this kind of video, then it belongs to category 1. If it is this video, category 2. So on and so forth, you are going to teach the computer just like how you are going to teach a small kid. Eventually, computer will be figuring it out on, if I get a new data which is of similar to this pattern, then I have to categorize that into category 1. This is how your machine learning is going to help you, because machines have computing capability. They do not have logical thinking capability. So you are going to give that thinking capability to computers as a developers. That's all you have to do as a data scientist, as a machine learning expert or an AI expert. You are training the computers so that they assist you in doing things which probably humanly may not be practically possible in a given limited time frame. Right? So that's a small example that I wanted to talk about. Next, these are a few things that you need to look at. I'm not sure if anyone has worked with these devices. Assuming you have, at least few % of people have looked into this. Let me ask a poll here. Let me take a poll. Okay, let me go to the poll. Okay. What is the size of the first floppy drive? Or I should say, what is a, yeah, I should say 20 MB. I will say 1.44 MB. I will say 700 MB. And I would also say 1 MB. Or I should say 1.5 MB. 2.5. That would be more appropriate. Yeah, please answer the poll, friends. Let me see. Because that is really exceptional in the options, is it? Okay. 2.5 MB, 20 MB. Okay, good. Nobody's saying 700 MB. Okay, nice. 20 MB is coming down. 2.5 MB is okay, still increasing, it's down. All right. So I used to work for, as I said, Oracle Corporation, and we used to do a lot of implementation, the software implementations. And this software was a very beefy software. Generally, it's big softwares that we were installing for our customers. Those days, we used to have floppy drives. A big box of floppy drives were there. Right? These are tape devices. And each of this tape device is capable of holding 1.44 MB, like majority of you people have said. So imagine my condition those days. I used to set up the software, and there were close to 35 floppy drives that I used to change. Right? So it says install the first floppy drive. I used to install it, start the setup, and as soon as the setup installation starts, it asks us to enter the second floppy drive, send it, put it, third, fourth, 35 floppies I used to put it. But those days were very good, friends. I was really happy because I used to have a bunch of floppy drives and I used to have a lot of data in that. Right? It used to be like so much of data. 1.44 MB data was like very good amount of data storage device. Later on, we had hard disks, right? We used to try and move these hard disks directly. Of course, that's a later point. After floppy drives, we had compact disks, then we got DVDs, then we got the flash drives, right? Memory-based, the chip-based flash drives. Now, in fact, your mobiles come up with micro SD cards, which are even less than your nail size, and they're capable to store 512 GB, half a terabyte storage. In fact, now mobiles are coming up with 1 terabyte storage space. So look at the transition, the digitalization that we are going through. We are lucky, right? We are lucky to see the digital transition that we are going through now. Probably, right, our past generations, they were not so lucky. And our future generations might see maybe even weird things that like COVID-19 or all those things that we are seeing. It could be even weird. But I would definitely say we are at this point of time really lucky to see how computers are changing. Computers are getting revolutionized, right? So this is called as a quantum computer, which a lot of organizations are now speaking about. Physics. I was very poor in physics. It talks about quantum physics. That's the technology which quantum computers are using. And this quantum computer the this processing unit is very small processing unit, but the device for the computation is very big. It's like a one complete room. You can see a YouTube videos, a lot of YouTube videos. IBM is showcasing their quantum computer, right, processing and all that. A lot of research is happening here. And you know why I'm talking about this specifically? Because of its capability to process the data. November 2019, if I'm not mistaken, yeah, it's November 2019 or December. Google has come up with a statement saying that they had a problem, some mathematical problem, which computers have to solve. And that would have taken 10,000 years, it seems. Right? It is a problem which would otherwise have taken 10,000 years if they used their computers. I'm talking about organizations, supercomputers. This is the complexity of the problem. But they claimed that their quantum computers solved it. Can you take a guess on what is the time? Has anyone read about this article? This particular quantum computer of Google said that, they claimed that this 10,000 years problem was solved under 4 minutes. I don't remember exactly, it was 3 point something. So it was under 4 minutes. Now imagine what happens to your supercomputers once quantum computers are coming into the picture. We are trying to compare the performance of a computer which is 10,000 years to 4 minutes. You can again Google it, right? Or if you're using any other search engines, you can do that. And you can read about those articles, right? So staggering speed, staggering technology. We are lucky to see all these things. And we are going to see a lot of additional things as well. Now, coming to the application part. Now, whenever we talk about analytics, right, friends, the analytics is classified into these 4 stages. It depends on what problem you're trying to solve using data. Data is the key. I keep on saying this. For the entire duration of the program, I would stress on the data itself, and I would repeat this statement. Data is new oil. As more data, they are going to become more powerful. Right? Now, the 4 stages of analytics are descriptive, diagnostic, predictive, and prescriptive. How do you understand this? Right? Let me explain this. You're trying to solve a problem. Okay, let's say you're working for a university. I'm assuming everybody is a faculty here. It's a faculty development program, so I'm assuming everybody is a faculty in a way or not. Now, let's say your dean of the university or management of the university is seeking some information from you, saying that, hey, what happened to the performance of the students last quarter? I want to see a report on that. Right? So this question would trigger you to generate a report. You are going to look back into the last quarter, look back into history. Right? And this history was stored in some softwares. The data is getting stored. You're going to look into the data and generate reports and say that, hey, XYZ XYZ is the performance. And you're comparing it with your right last year or maybe the current, and you're saying current time period, and you're saying that the last quarter we see that the performance of the students has dipped down by 10%. Or probably 20%. This is the question. What happened to the last quarter performance? And this is the answer. But immediate question that would come up from your management would be, why? Right? Human psychology says When you're trying to identify something, we also try to reason things out, isn't it? Now, this reasoning is called as diagnostic analytics. Report generation, trying to dig into the past and see what happened, is descriptive. Why that incident happened, trying to figure that out, is diagnostic analytics. But these both are reactive tasks. They are reactive. Incidents already occurred, and now you're reacting for those incidents. If you are basically proactive, you're going to say that, fine, I found that there's 20% dip in the last quarter, and because of the lockdown, we see that this dip has come up, and it is going to continue the same. So I predict that the performance is going down further. It's going to happen, it's going to go down to 30% next quarter. If you can upfront predict this and inform your management, then probably you can strategize a better solution. You prescribe, you come out with some solution to handle this. That's conducting a lot of workshops, trainings, online trainings, conducting online examinations, etc., etc. These are the solutions that you will be able to figure out if you are trying to figure out what would happen in the future, what is likely to happen. And if you know that, you'll already be able to fix that with your subject matter expert's help. These are the 4 stages. Now, I'm not sure how many of you have actually got these 4 stages. But again, I would love to explain this using another example. Again, this is my favorite example. Let's say a friend of yours. Okay, I don't want to take example as you. So I'm saying a friend of yours is suffering from cold. Now at this stage, at this time, suffering from cold, God help us, right? Treatment is not available, doctors are not available, etc., etc. You're on your own, right? Now we'll talk about a small example here. Assuming there is no lockdown, world is a normal place now. So a friend of yours, XYZ, is suffering from cold, is not good health-wise. So we take him to doctor. We visit a doctor. And in the first consultation, when you are trying to meet the doctors, when you're trying to have a conversation, doctor is asking you a bunch of questions. And what you do? When I say you, this XYZ, your friend, is trying to describe his symptoms. He's basically explaining what is his experience currently is, or past is. So description is happening here, describing the problem, what happened or what is happening. Then doctor says that, okay, go and get blood test, urine test, whatever the nonsense test that they would ask us to get it done. Very important tests, though we feel it is not required. But for doctors to confirm on what are the factors which are causing the problem, which are causing this discomfort for you, or sorry, your friend. To figure out the factors, we need to get these diagnostic tests that doctors are prescribing. Factor analysis, right? So this is reactive. Now, from this information, doctor can have a concrete decision or concrete idea on what exactly is causing the problem. And from this information, he would predict, saying that you might get a problem A, B, C, or your friend might get a problem A, B, C if the treatment is not given. So what he's doing here? He's predicting, forecasting, saying in future, you end up getting ABC problem. Now, because a doctor is a subject matter expert, he will give medicines, solution to your problem. When you are falling sick, you don't talk to your friends. You don't talk, of course, you talk to your friends, but you don't take consultation from them, right? We need specialists, doctors, who can give a proper solution to you, right? So the 4 stages of analytics starts right from descriptive and then goes into diagnostic. Generally, these two are coupled together. Using this historical information or the knowledge that we accrued from this historical scenarios, we try to predict the future, right? And then once I know the future, we will try to find out solutions as part of prescriptive analytics. So this is basically the 4 stages of analytics. Remember, you are looking into data science, data analytics, right? So these stages is what we are going to eventually try and address. I'll talk about this one example, and then probably we'll take a short break, okay? And then we will actually jump into the subject on how do we approach a business problem, right? We'll take some use cases and try to solve them. This is something everybody might have experienced, friends. We call this as a, in this example, we call it as a location-based analytics. If you look into this example, again, this is a classical example that we always try to give. I try to give, because it is very easy to decode and understand what analytics can help us to achieve, right? So let's understand this. Let's say you are a sports person, sports freak. Every day, right, you jog, you work out. And this is the track that you are running on. This is the track. Now you're wearing a smartwatch, remember, smart device, fitness device, which is capturing all this information for me. Yeah, it is capturing all this information. And yeah, we share this information in social media, public forums, saying that, hey, today we have worked out for right this much time and we have burned these many calories and etc. So that means the data is available for us to take advantage of. Some or the other way, of course, data security norms would be there. We are not getting into that discussion. But you'll have these scenarios, isn't it? Now, given this information, as a manufacturer, let's say I'm a manufacturer, I manufacture New Balance shoes, as you. I want to tap the customers. Now, if you remember your childhood days, right, probably 2 decades or 3 decades ago, as a customer, we used to go to businesses, right? We used to go to, let's say, footwear stores and all that and purchase shoes. Small example, any product. But now, our paradigm has changed. Businesses are chasing us, chasing end customers saying that, hey, why don't you purchase my product? Isn't it? So the entire paradigm has changed because of the competition. Now, in the same way here, I want to target my potential customers. If I don't target my potential customers, then I will be losing on business because my competitors will do that, right? And I don't want to lose any customer to my competitors. I have to survive. So how do I do this? So let's say you were jogging every day on 2.73 kilometers and you took 14 minutes, 16 seconds every day. But one fine day, you have taken 1 minute extra, 15 minutes, 24 seconds. Now, what does this basically tell us? It is like your heartbeat. It is like your right sine wave. Every day you're taking 14 minutes. It will basically go like this. But suddenly, one fine day, you have taken 1 minute extra. This is anomaly, friends. A variation in your pattern. This is something which is weird for your behavior, right? Your behavior says, or your pattern says, 2.73 kilometers, close to 14 minutes, here and there. But one fine day, 15 minutes. Now, there could be n number of reasons for this delay, isn't it? You might argue saying that hey, there could be n number of reasons. My manager has asked me to work on a deadline. I had to complete the task, so I slept a little late. Because of that, my body was not performing well. Probably you had a nice hangout party with your friends, bachelor party. Obviously, you'll be boozing and all that. I mean, people who do that. But you again have slept late. So in the morning, you'd not be able to give your best. Weather conditions could be the problem. N number of different things would be their reasons. But for me, I'm a manufacturer. I would want to believe that there was an issue with the shoe. Probably the shoe that you are wearing are worn out. Probably very old shoes, and they were not working well. This is my belief, but I want to make sure that belief was correct. So what I do, I ask Google, Facebook, all these forums to share me the information about potential customers. Now, let's say you are traveling in taxi. You boarded a taxi, Uber, Ola, whatever that is, you boarded a taxi, and you're searching for replacing running shoes. Because in fact, your shoes were worn out. That's the reason why you have taken 1 minute extra and you're not happy. So you want to immediately change the shoes. So you're searching for this. Now, Google would provide you these details. And they do not shy away. Whatever you ask, right? Google shares that information with you, right? And at the same time, Google is selling this information to me because I pay Google to say that, hey, tell me about my potential customers. So Google is sharing me your details. What network you are connected to, what is the IP address of that, which location you are currently searching the data from, right? Etc. etc. A lot of details are shared with me. Now, using that information, I try to tap to you. I try to market my product with you. So you are using, assume, free Wi-Fi, which is nowadays provided in the cabs. So you're going to look into this free Wi-Fi because you know IP address, you know what is the Wi-Fi that the customer is using. So you try to publish your ad in that particular television. Now, this is something we experience, isn't it? We are searching for some product and suddenly we see that product live on different web pages. Isn't it? That's not coincidence, friends. It's basically individual, right? Target marketing, what these businesses are doing. So they're trying to identify what is your behavior, what is your requirements. And based on that, they target you. Now, you were not interested. I mean, it's a coincidence, right? You're feeling that, okay, maybe a coincidence. I was searching for shoes and I see the shoe ad. So you might not get interested in brand, even though I'm trying to tap in with my ads. But I cannot ignore you. I cannot leave you. Because if I leave you, my competitors would try and tap you. Anyways, you want to purchase a shoe, right? So you might churn out to my competitors. So I don't want that to happen. So what I do again, I chase you. GPS coordinates are already known to me, right? The GPS coordinates will tell me exactly on where your cab is situated or located. Now, as soon as the cab takes this lane, I would flash an ad on this electronic billboard. This is an electronic television. We see nowadays a lot of these boards. And these ads will get populated when you require, not like regular intervals. Whenever you assume that there is a potential customer, right, who's passing through this lane, in such cases, you would want to, right, have your ad published there. Again, this is to make sure you attract your customer. I'm trying to attract you. But again, maybe you're not getting attracted. You've seen the ad, but you did not care. You are doing something else, busy. So what should I do? I have to be now desperate because I'm trying to tap you, grab your attention. But your attention is something that I'm not able to get it, right? So now we will try and publish personalized messages to you. Okay, I would try and give you a personalized message on your public profile, like your Twitter account, LinkedIn account, Facebook account. You see these messages, right? Only for you, discount coupons. Use this promo code, something like that. So I would give you the ad, I would give you the discount coupon, which would basically trigger you to purchase the product. Again, lockdown or no lockdown in that matter, we started moving digital platforms. We are purchasing things now online. So let's say you purchase a product on Amazon or any other e-commerce website. You purchase New Balance shoes, right? Again, new technology, 3D printing is there. These shoes are, let's assume, 3D printed and have to be now delivered to you. So Amazon has come up with a drone technology. They're delivering these products using drones nowadays. I mean, it's still pilot launch. This image that you're seeing is very, very, very old storyline. Amazon has done these experiments long time back, almost like 2017, 3 years from now, 16, 17. So they use these drones to deliver the products, right? So drone is a machine. It is getting trained enough to navigate to the destination, even though there are walls, even though there are electric poles, trees, birds, etc. It has to navigate appropriately and to deliver the product to the right customer, right? So that's the technology that we are talking about, friends. Machine learning, right? So this is a practical application of machine learning, data science. Let me show you a small video on something called as location-based analytics that we have been seeing, right? Let me just try and show you that. Sure, I have the video. Let me see if I can show you that. Location-based. Where is it? I don't see that. I think I have it in different location. Look at this. Okay, let me mute the line. Just look at what is happening on the screen. I'll try to explain here. If you see that the electronic billboard that you're seeing on the screen, right, was initially publishing something else. Yeah. Look at that. The kid starts getting up and he's pointing finger towards the plane which is flying on the sky. So what British Airways has done is they have tried to capture the information of the flights which are passing by in the sky, right? So they have this antenna set up which would basically act like a trigger zone. As soon as a flight passes through or passes into that zone, then it captures, this antenna captures the details of that particular flight, right? And then look at that. Yeah, this is the trigger zone. As soon as the flight enters into the zone, it identifies what is that right flight and where is it traveling from and to source and destination. And using the antennas, we basically try and publish that onto the screen. So there is another ad which is getting published. If you see here, there's LG phone ad is getting published, right? But that ad gets stopped and British Airways ad gets published because it has to show that flight, right? See, as soon as that flight starts, the kit points to that, right? So using IoT devices, using analytics, using real-time analytics, in fact, British Airways has come up with this unique way to do the marketing, right? So this is basically what analytics application can do to us. Yeah. All right. So we will take a short break now. I will show you more such interesting videos probably from the next time onwards. I would right, try to figure out the solution for the audio problems that we are facing, but we will try and learn on how do we implement an analytics solution for a given problem. We'll do that post the break. So in the meantime, I would want you people to just right, have this mind map handy. All right. Yeah. And I would also want you people to take the advantage of YouTube channel that we have. This is our channel, right? I would yeah, publish it in the chat window, right? So these videos that you're seeing has, right, in fact, you can see the live session is happening on YouTube now. Whatever the session that I'm doing, right, it is happening live. And we have a lot of such sessions conducted. So you might want to subscribe to this particular channel. Subscribe to it so that you get the notifications on when we are conducting new sessions as well, and what new sessions we are conducting. It's absolutely free, friends. You can just subscribe to this and take the benefit. All right. So it's 3:15 now. We will take a quick, probably 5 minutes break today. From tomorrow onwards, we'll have an extension, another 5 minutes extension. So we'll connect back in 5 minutes and we'll take the discussion further. All right. So 3:21, we will resume, friends. Yeah, in the meantime, if you have any queries, please post them. I will look into the queries as well. Hey, hi everyone. Assuming everyone is back. Okay, let me see if I can take the queries. Yeah, I'm trying to take the queries here. Okay. Mukhtar, we will be talking about those things. Today and tomorrow, we will be discussing about exactly that part. What data types are there? How do we measure those things, right? All those things will be covered. How can we make the future in data science after class 12? Okay, +1, +2. See, data science is all, you can say that data science is about becoming more smart. Data science is all about trying to take the advantage of data when some decisions are being made. Can we take some kind of a cue from our past? So if you have to introduce data science concepts right after class 12, then yes, we have to do, and I think AICT has already started doing that. Probably in your engineering graduation, first year students are trying to learn these concepts now. So it's a good start. In fact, CBSE syllabus has been modified. It has been upgraded, and class 8th and 9th standards syllabus has been right now some kind of AI been added into that syllabus. Artificial intelligence, analytics related concepts have been added into the CBSE syllabus. So we are moving in the right direction. And yeah, especially for technical students, people who want to get into the technical courses, they should start with Python programming. That would be a good start. Because future is going to be Python programming altogether. Mukhtar, as I said, we will be covering those things. Ramendra Nath, you probably are 1 hour late. Yeah. Yes. All right. So let me take a small poll and then we will start with the questions. With the new session, sorry, the continuation. How many stages of analytics did we discuss? How many stages are there? One, two, I should say 3 and 4. We discussed about stages of analytics, right? Let's see how many of you actually get the answer. Very simple questions, isn't it? Great, yeah. Wonderful, guys. Wonderful. All right. So let's start with the okay. Somebody is saying 3. I'm assuming it is a typo. Right. So that's just for fun. Let's move on. Right. So I have shared this link with you all. This is a mind map. We call it as a mind map, which basically gives you the holistic picture of a practical data science approach. Whenever you talk about any project, right, the project should basically talk about not just learning the concepts, not just developing the Python programming, but the deployment is very important. Deployment is the key, which industry is looking at. And if you are trying to get into developing a data science solution, analytical solution, then try and understand how you can deploy the solution also. There would be a lot of factors which come into the picture, right? So right from the first stage, right from the beginning of your analytical project discussions that you are having with your client, till the time you deploy it, right? It is a project that we have to cater to. And any project, we need to follow certain methodology. I'm pretty sure you might have heard about project management methodology. PMP, we call it as PMP, remember? PMP trainings are there. So there we have waterfall methodology, agile methodologies and all that. Similarly, for analytics project, any analytics project that we are trying to apply will follow this particular methodology called as CRISP-DM. CRISP-DM. CRISP-DM, friends. What is this CRISP-DM? Full form of that is Cross-Industrial Standard Process for Data Mining. Now, data mining is nothing but the approach or the process that we are going to do when we are trying to implement a solution in the space of data science. As a data scientist, you will be doing that. Right? Machine learning concepts will come into the picture. Deep learning concepts will be coming into the picture. Right? Descriptive, predictive analytics solutions that you are trying to develop. Right? Now, there are different other techniques. We also have something called as KDE, knowledge transfer, knowledge discovery, right? And then we also have SEMA, sample estimate, sample evaluate, model, all those things will come, accuracy, all those things will come. But yeah, most popular one is CRISP-DM, and this is what we are going to learn here, CRISP-DM. Now, this project management methodology, the steps of CRISP-DM, are broadly classified into 6 stages. Okay, 6 stages. We will have to understand each and every stage in detail in order to try and apply your solution. Now, the first step would always talk about understanding what your client needs. So understanding that exact business problem is important, right? How many of you have seen Chennai Express? Movie Chennai Express. I'm pretty sure everybody might have seen that, right? Shah Rukh Khan starter, Deepika Padukone and Shah Rukh Khan starter. Chennai Express. What happens there? In that movie, our lead actor Shah Rukh Khan wants to skip a ceremony and go to Goa with friends. He wants to go to Goa for party. But by mistake, he boards into a train which goes to Chennai. Isn't it? Now, from the actor's perspective, from our hero's perspective, he woke up early morning, he packed the luggage, he went to railway station, he boarded the train, everything he did as per the plan, as per his need, as required. But he went into a wrong direction. He landed up in Chennai rather than in Goa. Isn't it? So what we're trying to do is, or what we're trying to understand here is, if you are very clear on what exactly you need to do, right, then document it and follow those steps. Don't get diverted. That's understanding the business problem actually means. Right? Let's say another example. Let's say your students, there is a class, and there is an instruction to the class saying that, hey, students, you have to prepare for an exam. Right? And let's say the computers HOD is making this announcement. And assuming this computer or let's say professor, okay, let's talk about this. A professor is going into the class and announcing that there would be an exam tomorrow. There would be an exam tomorrow. Now this professor is, let's say, computers professor. He teaches, assume Python. Now he is going into the class and announcing that there will be an exam tomorrow. Now students, the class students, because of this exam, they prepared. Just like any other technology students or any other student, basically, they do the last hour preparation. So all the students have woke up late night and prepared Python. And the next day, when the exam was about to exam was about to start, right? We see, let's say, another faculty, probably RDBMS faculty is coming, and he started to take exam. What's going to happen? What's going to happen? All the students are going to flunk on that exam, right? Everybody is going to fail. Isn't it? Why? Because they prepared Python, they didn't prepare RDBMS. Instead of this, they prepared this. Why? Why did this happen? Because students make assumptions here. They made assumptions. Right? Because the announcement was done by a Python professor, a person who was, a professor who is delivering Python, he came and gave the announcement. Students assumed that it is going to be a Python exam. Now, students should have asked the question properly. When the announcement came, they should have asked on what examination it is going to be conducted. So questions are missing here. Because of their assumption, everybody is going to fail the exam. They put the effort, no doubt about it. They prepared very well in Python. If Python exam would have been conducted, everybody would have passed. Right? So understanding the requirements is very, very, very important, because the entire effort that you're putting in after that is going in a wrong direction if you are not understanding the exact requirements. Isn't it? Now, from the professor's perspectives, he would also have to give the right information. He was reading a paper, fine. There was an announcement. He was reading that announcement. But probably he would have added a point saying that there would be an exam on RDBMS. Don't assume that it is Python, because I am reading the announcement. Don't assume that it's going to be exam on Python. Prepare RDBMS. This clarity was missing, right? From both the sides. Students should have asked the question. Professor would have given more clarity. But you cannot ask the professor saying that, hey, why did you not give me the details? Right? You cannot go and ask the client saying that, hey, you did not give me more clarity. Client would say that it was your responsibility. You should have asked the relevant questions. Right? So, understanding the business problem and documenting is also very important. Okay? Because after some time, when you started putting effort, suddenly the requirement might change from the client. They might in midway say that, no, this was not what we discussed. We discussed something else. They might change their version. Isn't it? So we need to have documentation properly to evidence saying that, hey, no, this is what we exactly discussed and that's what we're trying to solve. We will work out on your new requirements if that is the case, but you have to acknowledge this. Right? So this evidence is important. So understanding business problems can be classified into these steps. It is all about defining the objectives. What are the primary objectives that you're going to solve? You have to document that. And when you're documenting those objectives, you'll also have to look at the conditions, constraints that would be there within which you have to come up with a solution. Right? Now let's say, I'll talk about one example. Again, very generic example. Let's say there is a bank, right? It has multiple services. One of the services, of course, credit card, and customer care would be there for that credit card department. Okay, and there is a roundtable conference happening, meeting happening. Every day they conduct these meetings, or every monthly once they conduct the meeting with the management. Now, in one such meeting, let's say July, all the stakeholders are sitting, the high-level management folks are sitting, and they're discussing. The customer care department of credit card, wing, he had a concern. He's saying that we have seen a lot of increase in incoming calls. We have seen a large volume of incoming calls. Lot of increase in incoming calls. What does that mean? Customers are calling, and what they are saying, they are complaining, saying that the transactions are happening without their confirmations, without their validations, OTPs and all that. So they are getting a lot of alerts saying that money is getting deducted from their credit cards. This is the concern that the customer has. I'm reading out whatever I'm writing. My handwriting is really pathetic. So yeah, if you're not able to understand anything that I'm writing, please, you can post your question. So credit card department, customer care wing, head of that wing is raising a concern saying that they are receiving a lot of calls of late, incoming calls, complaining that there are a lot of transactions which are happening on their cards without their confirmation. What does this business problem actually say? From the statement, can you try and understand what is the problem that the department has to now solve? Anyone? The bank is looking at a lot of fraudulent transactions, right? Fraud transactions. Now imagine you are receiving a message on your mobile saying that there's X amount of money deducted from your credit card. You are not doing the transaction, but you're getting an alert. That means it's a fraud transaction which is happening, right? So credit card department is seeing these issues now. Now, for this problem, you have to come up with a solution. As a data scientist, you have to come up with solutions. There might be a number of solutions. We will pick one solution, of course. So the solution has to be, right, for the problem to minimize, the objective is to minimize the fraudulent transactions. You're looking at a lot of fraudulent transactions. I'm writing it as XNS transactions. Your objective is to minimize this. But if you come up with the solutions, right, you can say that, hey, why don't you call customers? Whenever there is a transaction happening, why don't you call the customer? This is a simple solution that we can think of, isn't it? So that you can arrest immediately if there is a fraudulent transaction happening. If your customer says that, no, it is a genuine transaction, I did it, then fine. But as soon as the transaction is happening, and if you call a customer and ask him, and if the customer says, no, it is not something that I did, that means the transaction is a fraudulent transaction, and you can immediately alert the authorities or that particular department where the transaction is happening to, right, catch hold of the person who is trying to do this transaction. So you can control the fraudulent transactions this way. But there are challenges with this solution. Two challenges. The first challenge would be looking at this stuff. You need a high number of resources to give this kind of a solution implementation. You need to make calls, right? As soon as there is a transaction happening, you have to call the customer. But can you imagine how many transactions would happen at any given second if you have million customers, assume? So you need to have those many resources at hand. So this is cost to the company, cost to the bank. Already they are losing money because of the fraudulent transactions. On top of that, you're saying add more worse, right? More situation where you're going to, right, lose money on this. And practically it is not possible to give calls to all the customers at the same time. These are the two challenges in this problem. The second problem is you are causing inconvenience to your customers. Imagine you're receiving a lot of calls. For every small and big transaction that you're doing, your credit card department is calling you, right? And they're asking you on, hey, did you do the transaction? For every small and big transaction, if they do it over a period of time, you get irritated, isn't it? We get irritated. So these are the bunch of problems that we are having. So when you're documenting the business problem, when you're trying to understand the business problem and documenting it, always write the statements in small one-line statements and use optimization terms. It is recommended. So you're saying minimize. What you want to minimize? Fraud transactions. But how are you going to minimize? That is a question. Your constraints would be limited budget. Your constraint could be saying that it do not cause inconvenience to the customer. I don't want to hire new staff because I don't have money. I don't want to cause inconvenience to the customers because they will churn out. They will leave the organization. They will go to another credit card department, another bank. So these are the constraints. So objective says minimize the fraudulent transactions by maximizing the comfort to the customer. Or you can also say minimize the cost to the company. So maximize, minimize. These statements should be coming into the picture. Right? So maximize, and we are saying minimize. So you're minimizing fraud, minimizing cost to the company. Maximize, you're maximizing comfort to the customers. Now all this has to be documented, friends. If you're not documenting, over a period of time, once you start finding a solution, once you start implementing the solution, your credit card department might come back and say that, hey, no, I was looking for something else. This is not what I was trying to seek. Right? So the documentation is very, very, very important. And this documentation is called as project charter. All this understanding that you had based on the discussions that you are having with your client, you are going to document that. So here we'll have project charter. And this is responsible. This document is responsible to have all the details pertaining to that particular project, high-level details. It's like a reference guide. You would have the client details, you would have the project objectives, constraints, assumptions, technical stuff, non-technical stuff, server informations, timelines, budgetary constraints, let's say the team leaders or project manager. All those things will be there in the project charter. And this is your guide for your entire problem solution that you are going to develop now. Right? So this is the first step, friends. Understanding the business problem. Right? Now, based on the discussions that you had with your client, You're documenting these objectives and constraints. Now, you also have to try and understand what kind of data would you deal with. See, any solution that we are talking about has to deal with the data only, right? So what is the data that we are going to probably work, right, on this project? You have to imagine, you have to foresee. And that would basically come in when you understand the business problem better. Understand the factors that you are going to consider for your problem solution, isn't it? So we need to look at the kind of data that you're going to solve. Foreseeing, it's not confirming that yes, we will be looking into this data. We're assuming that this is the kind of data that we will be working on. And as part of this, the first thing would be looking at the data and understanding whether the data is going to be numeric or non-numeric. Is the data going to be numeric or non-numeric? And we call that as qualitative and quantitative data. Qualitative data and quantitative data. Numeric, non-numeric. The difference, right? Let's say a married couple. I'm pretty sure most of you are married. So I'm asking you a question on, hey, are you happy with your married life? What would be the answer? You're going to give the answer as yes or no. 99% you will say yes, right? 99% of the people are saying yes. I'm happy with my married life. This is qualitative. You can only describe this. But now let's put a quantifiable value to it. I want to measure the happiness now. So I'm going to ask you on rate your happiness on a scale of 1 to 5. Yeah. Now pretty sure a lot of people are going to say 1, right? So you are happy, yes. It is describing your married life. But how happy? You want to quantify it. This would actually give us better picture of the scenario, isn't it? So this is how we deal with qualitative data and quantitative data. So we are upfront looking at and right, the business problem and saying that, okay, I would be dealing with qualitative data. I would be dealing with quantitative data. So we are making that kind of a record. Making a note of that, because based on this data type, we are going to apply our solutions. Different solutions, different data. Okay. Then we also have to look at whether the data is structured or unstructured. Right? Now, structured data could be the bank transaction. So if I have to understand a solution for the fraudulent thing, I need to look into the transactions that the customer is doing. Right? So the bank transaction data would be recorded in a table representation in the bank. In the centralized, I mean, there would be a specific location where the data is getting recorded for all the customers. And this would be in a proper table representation. So let's say I'm purchasing a gold necklace for my wife, right? I wish. I'm not that rich. So gold, I'm purchasing gold for my wife. So the transaction is getting recorded here, which would become structured data, right? Now my wife wearing that gold necklace is sporting, taking pictures and sending it to me saying that, hey, look at my gold necklace. Thanks. You purchased a gold necklace to me. So that image becomes unstructured data, right? Probably she's sharing that on social media. So this becomes unstructured data because there is no table representation of the image, right? So this is the difference between structured data and unstructured data. In simple terms, do you have a proper data model defined for your data? Data model is nothing but table. Each column has a definition. If you have a proper predefined data model, then we call it as structured data. If not, if you cannot store the data into a table representation, then it is unstructured. So based on that, again, you will have to apply different techniques. So you are upfront looking into that as well. Then, if your data is big, then your traditional tools will not be handy, right? You would have to use specialized tools. But if you're dealing with not so big data, then your traditional tools will be good enough. SQL-based databases will be good enough if your data is structured and not so big. But if your data is very big, as I said, you will need specialized hardware, specialized tools. So that is also something that we need to cross-check. Then we are looking at whether the data is time series or cross-sectional. Time series basically means the data is getting collected in sequence of time. Whereas cross-sectional data basically means we are collecting the entire data at a given point of time, 1 minute. We take everything at one go, right? So that's cross-sectional data and time series data. We also have longitudinal data or panel data. We call it as panel data as well. This is like your GIS, Google Maps, for example, maps data, right? Next, we also have balanced versus imbalanced data case. Now, if you're looking into that bank transaction data itself, right? 100 transactions, if I look at, how many transactions do you think will be fraudulent transactions out of that? Yep. So these transactions, if you talk about 100 transactions, probably 1 or 2 transactions would be fraudulent. The remaining transactions would be genuine transactions, right? Good transactions. So if you're trying to learn the pattern for fraudulent transactions, what can you do? Only 2 transactions, right? You will not be able to learn on that, right? So we need to have some kind of special techniques to handle this imbalance, because I'm saying 98 transactions are good transactions, 2 transactions are fraudulent transactions. Your machine can get proper training on this. It looks into various scenarios, but only 2 cases of fraudulent, not much of training that is given, right? So that's balanced versus imbalanced cases. Another scenario, also something that you have to evaluate, is whether the data that we are looking at is consumed as batch offline data or online data. Offline data basically means you're doing batch processing, whereas online data means you are doing real-time processing. As and how the transaction is happening, you're trying to find out whether it is fraudulent or not, right? So that's called as real time. What all transactions did a customer did last day, that would be your batch processing. So based on your business requirements, the objectives that you are defined, you're going to try and see what solutions have to be applied and what kind of data you're going to work with. Now, once you got a high level understanding of these 2 cases, if this is as part of your business understanding only, once we deal with this is where, after this, right, this is where we go for data collection, right? We'll try to collect the data once we have good clarity on these things. Right? Yeah. So again, we will be discussing more about these things. And tomorrow we will look into the data collection aspects. And we will also talk about various data cleansing tasks that we need to perform. Right? Now, let me take your questions for the day. Okay, what questions do we have? Yeah, please ask your questions, friends. Let me see. Attendance link, okay. Mind map link, okay, fine. Let me share you that mind map link. Here you go. This is the mind map link. And you have Google Forms link on the sticky note at the top here. You might want to access that sticky note and right, provide the details. Yeah, just try it now. I think the permissions are handled now. Okay, next, let me look into the questions. Okay, permissions are basically given now. Please check, friends. Please check it now once. Okay. What is semi-structured data? Any example? Okay, wonderful question. Let me look into that. Let me answer that. So structured data, you clearly understand, right? Can anyone give me an example of structured data, friends? Anyone can give me an example of structured data? Okay, let me give it. It's nothing but table. Structured data means the data which your computer can directly understand, and that is only tables. Because formal definition for each column is given in table. In SQL databases, or you can say RDBMS databases, we have these tables where formal definition is given. That's nothing but schema for each column is defined. Right? So that's your, okay, let me write this here. Sorry, yeah. This is your structured data. Unstructured data, we clearly have understood. It is image, videos, audio files, text images, text files, etc., etc., where you do not have any schema information provided. Now coming to semi-supervised, there is something which is, semi-structured, which is falling in between structured and unstructured. Semi-structured basically means there would not be any formal definition upfront given, but we can define that formal definition very easily. In simple terms, if you look at XML file or a JSON file, XML will have data, but that data will be in semi-structured format. It has definition. In XML also we have tags. Definitions would be there, but your computer cannot directly understand it. Right? It's semi-structured. In fact, your CSV file, if you talk about a CSV file or an Excel file, for humans, we can read the data. We can see the data and understand what is each column. But your computer cannot directly understand the data unless until you define the columns using schemas. That's a detailed explanation of semi-structured data. Continuous and discrete data, Soundarya, we will be discussing that tomorrow session. We'll have to do a few more things. And as part of the pre-processing, we will try and understand that. Employee, bank transaction, employee. In bank transaction, probably banks do not record any semi-structured data because it's a formal definition, defined process. For banks, they don't have any semi-structured data here. Attendance data, relational data, tabular format, very good. Yes, wonderful. Yeah. All right. Please mark your attendance, everyone. This is required. I will also need your email IDs so that we can provide you the access. Mukhtar, as I explained, unstructured data basically means image data. Image data or any data which cannot be directly loaded into a table representation. You cannot define schema directly for an image. That's basically your unstructured data. Right. Any other questions? Any more questions, friends, please? And yeah, this is my LinkedIn profile. Let me share it again if anybody wants to connect with me. That's my link, my profile link. It's there on the sticky note, Dr. Varsha. Mukhtar, I didn't get your question. Purchasing date? What do you mean by that? Okay, let me share the link also. It's there on the sticky notes of your chat window, friends. I'm not able to, yeah. Yeah, this is the link. Yes, Hafiz, we will have. Yeah, we just started to understand the background of these concepts, right? So going forward, we will look into the hands-on as well. Using Python, we will be doing that. Yes, Harish, we will be learning on Python. So I will be explaining on Python as well. Amuta, I have shared the link chat window. You can see that chat message that I have pinged. Click on that link. All right. So let's conclude the day. Please share that. Please update your attendance. Again, once again, the link has been shared. And let's connect tomorrow, friends. Until then, thank you so much, and please stay safe. Good evening. Thank you. Yeah, Nishant, we will be doing that. Yes, Nishant. We are basically looking into such examples, right? Hey, thank you, Mr. Balachandra. Thank you, Dr. Barsha. We'll connect tomorrow. We'll have more exciting details discussing tomorrow. Please connect back, and yeah, thank you.